Hello everyone, welcome to Tech with Shaping Pixel. We are bringing you free cloud certification crash course. This time we are bringing AWS Certified Solution Architect Associate exam. So the best way to gain this certification is to complete this crash course and prepare the 400 real exam questions provided in this video. This video is specially curated to help you pass the AWS Certified Solution Architect Associate exam. So are you ready to take your cloud solutions design skills to the next level? The AWS Certified Solution Architect Associate exam is the perfect way to validate your expertise in architecting secure, resilient, high performance, and cost optimized AWS solutions. This certification exams covers four key domains: design secure architectures, design resilience architectures, design high performance architectures, and design cost optimized architectures. Each domain is crucial for demonstrating your efficiency in creating robust and efficient cloud solutions using AWS services. Each domain carries a specific percentage weighting within the exam, along with task statements outlining required knowledge and skills. So domain 1, design secure architectures. These domain accounts for 30% of the exam content and focuses on three key areas: design secure access to AWS resources, design secure workloads and applications, and determine appropriate data security controls. Domain 2, design resilient architectures. This domain accounts for 26% of the exam content and focuses on two key areas of interest: design scalable and loosely coupled architectures, and design highly available and fault tolerance architectures. Domain 3, design high performing architectures. These domain accounts for 24% of the exam content and focuses on the following five items: determine high performing and scalable storage solutions, design high performing and elastic compute solutions, design high performing database solutions, determine high performance and scalable network architectures, and determine high performing data ingestion and transformation solutions. Domain 4, design cost optimized architectures. These domain accounts for 20% of the exam content and will assess you in four areas: design cost optimized storage solutions, design cost optimized compute solutions, design cost optimized database solutions, and design cost optimized network architectures. Here are some of essential tips to help you succeed. With 65 questions to answer in 130 minutes, that's about 2 minutes per question. Remember, some questions are quicker to read and answer, and so use your time wisely. Scoring and domains. A passing score is 720 points out of 1000, and the questions fall into four domains. Be sure to focus your preparation on all domains equally. Keep in mind that the exam may include non-scored questions for statistical purposes. Stay focused and confident throughout the test. Good luck. So let's get ready to ace the AWS Certified Solution Architect Associate exam with our comprehensive crash course. So let's cover some compute services in AWS: Elastic Compute Cloud EC2, Elastic Container Service ECS, Elastic Container Registry ECR, Elastic Container Service for Kubernetes EKS, AWS Elastic Beanstalk, AWS Lambda, and AWS Batch. So master these essential compute services for the exam. Let's dive into the world of Amazon Elastic Compute Cloud, or EC2. Let's explore the key components of these essential AWS service. Amazon Machine Images. First up, let's talk about Amazon Machine Images or AMIs. These are pre-configured templates that allow you to quickly launch new EC2 instances based on specific configurations. With a wide range of operating system and applications, AMIs are the foundation of your EC2 instances. Once you have selected your AMI, it's time to choose an instance type. These defines the size and parameters of your instance, including CPUs, memory, storage, and network performance. The flexibility to choose from different instance families ensures optimal performance of your applications. Now let's explore the various purchasing options for EC2 instances. From on-demand instances to reserved instances and spot instances, each option is designed to help you optimize cost based on your deployment needs. Lastly, whether it's shared tenancy by default or dedicated tenancy for specific security and compliance requirements, understanding tenancy is crucial when launching your EC2 instances. Let's dive into Amazon EC2 Container Service, also known as Amazon ECS. Amazon ECS allows you to run Docker-enabled applications packaged as containers across a cluster of EC2 instances without the need to manage a complex cluster management system. AWS Fargate abstracts the burden of managing your own cluster management system, while Docker automates the installation and distribution of applications inside Linux containers. Containers are portable, lightweight, and scalable across a cloud environment, ensuring applications run as expected regardless of deployment location. So choose between Fargate Launch for simplicity or EC2 Launch for greater customization and control over parameters. AWS CloudWatch monitors metrics against your containers and clusters, allowing for easy creation of alarm based on specific events. Amazon ECS clusters are dynamically scaled within a single region, allowing for deployment based on resource and availability requirements. So let's dive into the Elastic Container Registry. Our ECR is a fully managed service provided by AWS. It offers a secure and centralized location for developers to store and manage their Docker images. This service seamlessly integrates with the EC2 container service, providing a hassle-free solution for distributing and deploying Docker images across applications. ECR eliminates the need for developers to provision infrastructure as AWS manages the entire process. It empowers developers to efficiently push, pull, and manage their Docker image library in a secure environment. Now let's dive into Elastic Container Service for Kubernetes, also known as EKS. Kubernetes is an open source container orchestration tool designed to automate, deploy, scale, and operate containerized applications. It's capable of managing tens, thousands, or even millions of containers, and it's container runtime agnostic, meaning it can run both Rocket and Docker containers. EKS is managed service provided by AWS, allowing you to run Kubernetes across your AWS infrastructure without having to manage the Kubernetes control plane. You only need to provision and maintain the worker nodes. So let's see how the Kubernetes control plane works. Let's dive into and understand the key components that make it all happen. The Kubernetes control plane consists of various components such as different APIs, kubelet process, and the Kubernetes master. These components are responsible for facilitating communication within your cluster and managing the schedule of containers onto nodes based on their compute requirements. In EKS, AWS takes charge of provisioning, scaling, and managing the control plane. They ensure resilience by utilizing multiple availability zones. These means your control plane is in good hands, allowing you to focus on your applications. In Kubernetes, worker nodes are the backbone of your cluster, responsible for running containers managed by the control plane. Each node is an on-demand EC2 instance equipped with Docker, kubelets, and AWS IAM Authenticator for security as a customer. Managing these nodes within EKS is crucial. Once provisioned, the worker nodes seamlessly connect to EKS using an endpoint. So let's learn about AWS Elastic Beanstalk, which is an AWS managed service that simplifies the process of deploying and scaling web applications. It allows you to upload your source code and configure the environment, while it takes care of provisioning and deploying the necessary AWS resources such as EC2 instances, auto-scaling groups, RDS database instances, and Elastic load balancers. For developers and engineers who may not have extensive AWS experience, Elastic Beanstalk provides a straightforward solution for deploying, provisioning, monitoring, and scaling web applications. It's a quick and effective way to get your applications up and running without the need for in-depth infrastructure management. With AWS Elastic Beanstalk, deploying web applications become a seamless process, allowing you to focus on your code and application functionality. So let's dive into a quick overview of AWS Batch. AWS Batch is designed to manage and run batch computing workloads within AWS. It's ideal for tasks like training machine learning models or conducting large-scale data analysis. In a cloud environment, maintaining a batch computing system can be complex and costly. However, with AWS Batch, you can seamlessly create a cluster of compute resources that's highly scalable and takes advantage of the elasticity of AWS. With AWS Batch, AWS handles all the provisioning, monitoring, maintenance, and management of your clusters, making it a powerful and efficient tool for batch processing. Some of the key components of AWS Batch are: the first component is a job, representing a unit of work to be run. These could be a Linux executable file, a Docker container image, or a shell script. Jobs run as containerized applications, which you can choose to run on AWS Fargate EC2 resources or an Amazon EKS cluster. In most cases, Fargate is the ideal choice as it allows AWS to handle all infrastructure specifics. However, larger scale jobs are those requiring specific architecture or direct access to processors or GPUs may need EC2 main instances. You can set up references and dependencies between jobs, allowing you to wait until one job is finished before starting the next one. Jobs can be various states, including submitted, pending, running, and failed. Have you ever wondered how to seamlessly integrate your on-premises environment with the AWS cloud? Let's dive into the world of AWS Outposts. AWS Outpost is all about bringing the capabilities of the AWS cloud to your on-premises data center. It allows you to use native AWS services, tools, and APIs within your local infrastructure, offering a consistent hybrid cloud experience. Outposts are available as 1U or 2U rack mountable servers or as entire 42U racks that can be scaled to deployments of up to 96 racks. AWS is responsible for securing the Outpost rack infrastructure, while customers are responsible for securing the applications they run on Outpost. Outpost may be connected to AWS using either a direct connect or VPN connection, ensuring a secure and reliable link to the AWS cloud. So whether it's for latency, security, or governance requirements, AWS Outpost provides the bridge between your on-premises environment and the AWS cloud, offering a seamless hybrid cloud solution. AWS Outpost offer a range of services including ECS, EKS, S3, RDS, and EMR, all available on premises. Customers can securely connect to other services and resources using private link gateway endpoints such as DynamoDB. Additionally, Outposts support EC2 with various instance types like M5, C5, and R5, along with storage options for EBS volumes, local disk, and local instance storage. Outposts enable migration and disaster recovery scenarios through Cloud Endure, allowing workloads to fail over in the event of an outage. It also supports VMware Cloud on AWS, providing a secure and scalable hybrid cloud infrastructure. Plus, AWS manages patch updates, eliminating the need for manual maintenance. Customers can conveniently order Outposts through the AWS Management Console, selecting from different compute and storage options based on their requirements. It's important to note that an enterprise or enterprise on-ramp support plan with AWS is required to place an order. In AWS, there's EC2 auto-scaling for scaling the EC2 fleet and an auto-scaling service for Amazon ECS tasks, DynamoDB tables, and Amazon Aurora replicas. Let's consider a scenario where a single EC2 instance acts as a web server. As the demand increases, the CPU utilization rises, requiring additional processing power. With auto-scaling, a metric can be configured to automatically launch a second instance when the CPU utilization reaches a certain threshold, ensuring load balancing and optimal performance. Auto-scaling offers automation, greater customer satisfaction, and cost reduction. It automates provisioning based on custom-defined thresholds, ensuring elastic resource provisioning. This prevents manual deployment and removal of resources. It also enhances customer satisfaction by preventing performance issues during demand spikes and reduce cost by automatically scaling resource based on demand. Let's dive into the complexities and different methods of autoscaling to ensure how architecture's performance is top-notch. Autoscaling is the glue that makes the well-oiled machine work, allowing you to manipulate and modify the number of instances within an autoscaling group in four different ways. First, you can manually adjust the variables, then schedule scaling to happen at certain times of the day. There's also dynamic scaling, which is automatic, and finally, predictive scaling, utilizing machine learning to provision instances based on training data. Each method has its pros and cons, and understanding when and where they have their place is crucial for a fault tolerance architecture. Manual scaling. When you know a traffic spike is coming, manual scaling lets you proactively adjust your fleet size, reducing downtime for users and ensuring a smooth experience. However, it's not a scalable solution for everyday use. It's best suited for rare, planned events, not long term management. So, while manual scaling can be a lifesaver for those unexpected traffic surges, auto scaling remains the go to for day two operations. While predictive scaling aims to anticipate load increases, provisioning new instances before they are needed. This is achieved through machine learning, which learns traffic patterns and adjusts scaling accordingly. Ideal for cycling and recurring workloads, predictive scaling is effective for traffic patterns such as normal business hours or batch processing. It utilizes historical data from CloudWatch, creating daily forecasts based on recent metrics. Test predictive autoscaling in forecast only mode to see its predictions without taking any actions. Evaluate the forecast and compare it to actual data using the EC2 autoscaling console. So consider using both predictive autoscaling and dynamic autoscaling simultaneously for a comprehensive approach. While this may increase cost, it can enhance user experience and ensure high availability. If you're looking to optimize your cloud architecture, time-based or scheduling scaling is a game changer. Scheduled scaling allows you to add or remove instances from your auto-scaling group based on specific time parameters. For instance, you can schedule the batch processing instances to come online during off-peak hours when spot instances prices are lower, saving your money. Scheduled scaling is a powerful tool for cost reduction. By turning off dev environments after business hours and scheduling them to turn back on in the morning, you can avoid unnecessary instance usage. This approach not only saves cost but also promotes efficiency by ensuring resources are only active when needed. You can even combine scheduled scaling with dynamic scaling for maximum efficiency. For example, you can have dev and test environments set to turn and on and off at specific times, while using dynamic scaling during the day to adjust the number of instances based on workload requirements. So by leveraging scheduled scaling, you can significantly reduce cost and optimize resource usage within your cloud architecture. So let's dive into AWS Elastic Load Balancer service. The main function of an Elastic Load Balancer, or ELB, is to evenly distribute inbound requests across a group of targets, such as EC2 instances, Lambda functions, IP addresses, or containers. Using an ELB strengthens infrastructure, helps with unpredictable spikes, traffic spikes, and provides high availability. It automatically scales to meet incoming traffic. There are three types of ELBs: application load balancer, network load balancer, and classic load balancer, each with specific features and use cases. Listeners, target groups, rules, and health checks are essential components of an AWS ELB, ensuring efficient routing and resource management. By understanding the AWS Elastic Load Balancer service, you can optimize your infrastructure for better performance and resilience. So let's do a short overview of server certificates. The application load balancer provides a flexible feature set for web applications running the HTTP or HTTPS protocols. When using HTTPS as a listener, additional configurations is required. So to recycle encrypted traffic over HTTPS, the ALB needs a server certificate and an associated security policy. The server certificates used by the ALB are X.509 certificates provisioned by a certificate authority, such as the AWS Certificate Manager service. When selecting HTTPS as your listener, you can choose a certificate from ACM, upload a certificate to ACM, choose a certificate from IAM, or upload a certificate to IAM. ACM simplifies the configuration process and is the preferred option. If deploying ELBs in regions not supported by ACM, you can use a third-party certificate by using IAM as your certificate manager. These adds flexibility for third-party certificates. So let's understand the application load balancer in AWS. The ALB operates at layer 7, the application layer of the OSI model. It provides advanced routing and visibility features for application architecture such as microservices and containers when used in HTTP or HTTPS. Before configuring your ALB, it's good practice to set up your target groups. A target group is simply a group of resources that you want your ALB to route requests to. To create a target group, go to the EC2 service, select load balancing, then target groups. Configure the target group settings, including the target type, protocol, VPC, and health check settings. To create an application load balancer, go to the AWS Management Console, select load balancing, then load balancers. Follow the steps to configure the ALB, including setting up listeners, availability zones, security settings, and associating target groups. The ALB in AWS provides a flexible feature set for advanced routing and visibility features. So by understanding how to configure target groups and create an ALB, you can effectively manage and optimize your application architectures. Now let's dive into Network Load Balancer in AWS. It's a powerful tool for balancing incoming traffic to your target groups. Unlike the application load balancer, the NLB operates at layer 4 of the OSI model, balancing requests based on TCP and UDP protocols. These makes it an excellent choice for application running ultra high performance and a static IP address. Now let's walk through the process of setting up a network load balancer in the AWS Management Console. First, navigate to EC2 under Compute, then under Load Balancing, click Load Balancers, select Create Load Balancers and choose Network Load Balancer. Configure the listener, availability zones, security settings, routing, and target group. Once everything's set, click Create to provision your network load balancer. With the NLB, you can efficiently manage and balance incoming traffic, ensuring high performance and reliability for your applications. Let's have a quick understanding of Classic Load Balancer in AWS. The Classic Load Balancer supports TCP, SSL, TLS, HTTP, and HTTPS protocols. It's best practice to use the ALB over the Classic Load Balancer unless you have an existing application running in the EC2 Classic network. To create a Classic Load Balancer, go to EC2, then Load Balancers and select Create. Configure the listener, availability zones, security groups, health checks, and associate instances. The Classic Load Balancer offers support for EC2 Classic, TCP, and SSL listeners, and sticky sessions using application generated cookies. Let's explore the crucial relationship between ELBs and EC2 autoscaling. ELB and EC2 autoscaling are essential for optimal efficiency, providing dynamic load management and elastic scaling based on demand. Each service solves specific operational challenges, but when combined, they work seamlessly to manage and scale EC2 compute resources. Without autoscaling, an ELB requires manual management of resource targets based on demand, creating operational burdens. Conversely, without an ELB, autoscaling struggles to evenly distribute traffic to the EC2 fleet, leading to inefficiencies. So by associating an ELB with an autoscaling group, the ELB automatically detects instances and distributes traffic, ensuring efficient resource utilization. Are you curious about how AWS services are driven by customer needs? Let's take a closer look at the customer driven innovation behind the AWS Gateway Load Balancer service. The AWS Gateway Load Balancer service is a prime example of customer driven innovation. Customers face challenges with the deployment process and scaling for virtual appliances, leading to the development of these essential features. Two key features were identified as essential for the AWS Gateway Load Balancer service. The first is VPC ingress routing for the Internet Gateway, allowing traffic to be forwarded to a gateway load balancer by updating route table in a VPC. The second feature addresses IP tunneling to ensure seamless traffic redirection without interrupting normal flow and interactions. The gateway load balancer provides a single point of access for all inbound and outbound traffic, enabling seamless scaling of virtual appliances based on demand. It also allows for the addition of custom logic into any networking path in AWS, providing flexibility and control. In conclusion, the AWS Gateway Load Balancer service exemplifies how customers' needs drive innovation, resulting in scalable, flexible, and transparent solutions for managing network traffic. Ever wondered how the Gateway Load Balancer and Genie protocol work together to protect your network traffic? Let's dive in and break it down. The Gateway Load Balancer consists of two parts: the VPC Gateway Load Balancer endpoint and the actual Gateway Load Balancer. The VPC gateway load balancer endpoint is defined in the VPC to protect the traffic, while the gateway load balancer sends traffic to a fleet of EC2 instances running third-party network appliance software. To make this happen, the gateway load balancer uses the Geneve tunneling protocol. Geneve creates a layer 2 logical network encapsulated in UDP packets, providing extensibility and leveraging network interface cards for performance improvement. A tunnel is established between the gateway load balancer and the fleet of instances on the backend. Traffic is encapsulated and sent through the tunnel to the security appliances implemented in EC2 instances, which examine and act on the packets. Geneve uses port 6081 for traffic and HTTP port 80 for health checks. And that's how the gateway load balancer and Geneve protocol work together to ensure the security and smooth flow of your network traffic. Introducing the gateway load balancer. The gateway load balancer endpoint GWLBE is defined in its own subnet per availability zone. It can be added to a route table as the next hop and integrated into the traffic flow of a VPC. The gateway load balancer endpoint operates across multiple accounts and VPCs with centralized control and administration. It's similar to AWS Private Link and plays a crucial role in integrating the security VPC into the traffic flow. To set up a gateway load balancer, provisioning a dedicated VPC and third-party virtual appliance software on EC2 instances. Then provision the gateway load balancer and target groups similar to other elastic load balancers. The gateway load balancer endpoints are created in dedicated subnets, updating route tables to integrate them into the traffic flow. So what's the deal with serverless compute? Well, to really understand it, you have to first understand servers. Imagine all the work that goes into running an EC2 instance, installing software, patching, scaling, and more. Now think about that maintenance and administration going away, allowing you to focus solely on your code and business logic. That's the idea behind serverless. So let's focus on AWS Lambda. It's made up of functions representing your business logic, and you can configure important details like permissions and power allocation. To upload your code, you can write it directly in the service or upload via a zip file on or Amazon S3. The programming language must match the runtime you select. So let's fully understand AWS Lambda. AWS Lambda supports several runtimes like Java, Go, Node.js, C Sharp, Python, and Ruby. If you want to use a language not on that list, you can bring other languages using the custom runtime API. This feature allows running PHP or C in Lambda. Your function can be invoked directly through the console, SDK, AWS toolkits, or CLI. It can also be invoked using a function, URL, an HTTP endpoint, or automatically by trigger like an AWS service or resource. Once triggered, your Lambda function can make calls to downstream resources like Amazon DynamoDB, Amazon SQS, and Amazon SNS. The server automatically monitors your function through logs and metrics, and you only pay for what you use, request duration, and compute power provisioned. So with AWS Lambda, you have the flexibility to choose your runtime, various invocation methods, and you only pay for what you use. Looking to invoke a Lambda function but not sure how? Let's explore the different ways you can do it. You can invoke a Lambda function directly using the console, CLI, SDKs, or automatically using a trigger like an AWS service. For synchronous invocations, you can use the request response model, perfect for maintaining order and waiting for a response. The asynchronous model, also known as the event-based model, is ideal for running functions that don't need to wait for a response. It offers automatic retries and a built-in queue. Lastly, the stream model or pool-based model, it great for processing messages from stream or queue-based services like DynamoDB streams or Amazon SQS. So whether it's synchronous, asynchronous, or stream-based, there's a Lambda invocation method that's right for your specific use case. Let's dive into monitoring and troubleshooting with AWS Lambda. When it comes to monitoring and troubleshooting with Lambda, a lot of important metrics are already configured with CloudWatch by default and built into the Lambda dashboard. There are three main categories of metrics: invocation metrics, performance metrics, and concurrency metrics. Invocation metrics are related to the outcome of the invocation. For example, there is a metric called invocation that tracks the number of times the function has been invoked, and the errors metric counts the number of failed invocations of the function. Performance metrics provide details about an invocation, including duration, which measures how long the function runs in milliseconds, and the iterator age metrics, which measures the time it takes for Lambda to receive a batch of records. Concurrency metrics include the concurrent executions metric, which calculates the total sum of concurrent executions at any point in time. In addition to these metrics, CloudWatch also gathers log data sent by Lambda to help you better understand, troubleshoot, and understand issues. Each function running in Lambda will have its own log group in CloudWatch. Let's dive into the world of serverless applications with the AWS Serverless Application Repository. The AWS Serverless Application Repository is a managed repository for serverless applications published by AWS, AWS partners, and third-party developers. These applications make use of Lambda API Gateway and DynamoDB without the need to provision or manage any infrastructure. Developers can browse or search the repository to find the applications they need, saving time and effort. They can also publish their own applications, promoting reuse within their teams or sharing them with the wider developer community. When deploying applications from the repository, developers can specify custom configuration parameters and manage them directly from the AWS Management Console. So whether you're looking to streamline your development process or share your innovative applications, the AWS Serverless Application Repository has got you covered. So are you familiar with the components that make up the AWS global infrastructure? So let's dive into the world of AWS availability zones, regions, edge, locations, and more. AWS availability zones are the physical data centers of AWS, each with at least one other availability zone geographically located within the same area, linked by highly resilient and low latency private fiber optic connections. Regions are collections of availability zones geographically located close to one another, allowing for low latency connections. Every region will contain at least two availability zones. Edge locations are AWS sites deployed in major cities across the globe, primarily used by end users to reduce latency for accessing services. Local zones are a new type of infrastructure deployment designed to place core AWS services near highly populated areas that do not already have an AWS region nearby. Wavelength zones are embedded within 5G mobile broadband networks that are deployed within the data centers of large telecommunications providers. Understanding these components is crucial for deploying services on AWS. So stay tuned for more insights into the world of cloud computing. So let's see why there are so many different AWS storage services to choose from. More and more organizations are moving to the cloud for its flexibility, scalability, cost efficiencies, and security benefits. AWS offers a wide range of services covering compute, storage, database, and network, providing core infrastructure elements. So, AWS provides different storage services to cater to specific needs, offering varied benefits and features such as cost, variance, security, durability, accessibility, and use case. Understanding the difference between block, file, and object storage is crucial for selecting the most appropriate AWS storage services for your needs. Amazon Simple Storage Service, also known as S3. Let's dive into the key features and functionalities of this widely used storage service provided by AWS. Amazon S3 is a fully managed object-based storage service that is highly available, highly durable, and cost-effective. It offers unlimited storage capabilities, making it extremely scalable. The service operates as an object storage service, meaning each object uploaded does not conform to a data structure hierarchy like a file system would. Objects stored in S3 have a durability of 99.9999%, known as 11 nines of durability. And the availability of S3 data objects is dependent on the storage class used, ranging from 99.5% to 99.99%. To store objects in S3, you first need to define and create a bucket, which acts as a container for your data. Each bucket name must be completely unique globally. Once you have created a bucket, you can begin to upload your data within it. You can also create folders within the bucket to aid with categorization of your objects for easier data management. Amazon S3 is a powerful and versatile storage service that offers a wide range of features for managing and storing data. Welcome to an overview of Amazon S3 storage classes. Amazon S3 offers a range of storage classes, each designed to meet specific performance and cost requirements. Let's dive into the different storage classes available and their unique features. The S3 standard storage class is ideal for high throughput and low latency access with 99.99% availability and 11 nines of durability across multiple availability zones. It also supports SSL for data encryption and lifecycle rules for automatic data management. For unpredictable data access patterns, the S3 intelligent tiering class optimizes storage costs by automatically moving objects between infrequent and frequent access tiers based on usage. S3 standard infrequent access. This class is designed for data that doesn't require frequent access, offering high throughput and low latency at a lower cost than S3 standard. S3 Glacier is a cost-effective archival storage solution, providing 11 nines of durability and multiple retrieval options based on urgency and cost. The Deep Dive Archive class is the cheapest option, focusing on long-term storage with retrieval times within 12 hours. When selecting a storage class, consider the criticality, durability, reproducibility, and access frequency for your data. So welcome to this quick guide on understanding S3 bucket versioning. So S3 bucket versioning allows for multiple versions of the same object to exist, providing a safety net against accidental or malicious deletion. To enable versioning, simply select the checkbox during the creation of new bucket or enable it on an existing bucket within the AWS Management Console. Once enabled, you can review all versions of an object and manage them easily within the console. So keep in mind that enabling versioning will incur additional storage costs due to storing multiple versions of the same file. Understanding S3 bucket versioning is crucial for managing your objects effectively and ensuring data safety. Let's dive in and find out what server access logging is all about. Server access logging captures details of requests made to a bucket and its objects. It's crucial for security, incident analysis, and meeting audit requirements. Enabling it is simple using S3 Management Console. Just select your bucket, go to the Properties tab and enable the Server Access Logging tile. Then choose a bucket, target bucket, and an optional prefix for organization. Specific permissions are required for S3 to write access logs to the target bucket. Remember, source and target buckets should be in the same region, and different buckets are recommended for each also. Encryption should be set to SSE S3 for logs to be delivered. When the logs start arriving in the target bucket, they follow a standard naming pattern. For example, if you set a target prefix of logs, all logs will start with that prefix, followed by the naming convention that includes the date and a unique string. So welcome to a quick guide on configuring S3 buckets to host a static website. To start from the properties page of your chosen S3 bucket, select the static website hosting tile. By default, the static website hosting is disabled. When this tile is selected, you are presented with three options: use this bucket to host a website, redirect request, and disabled. If you select the option of use this bucket to host a website, you need to provide additional parameters in its configuration, such as adding an index document and an error document. For people to be able to access your website hosted within your S3 bucket, then the bucket must be accessible to the public. By default, S3 buckets are blocked to the public. You must edit these settings and uncheck the block all public access settings. Save and confirm those changes. Once your bucket is publicly readable, you will then need to add a bucket policy to allow the public to read your objects within your bucket. So at this stage, you would have added your index.html document, configured your bucket to be publicly accessible, and also added a bucket policy to allow the objects within your bucket to be accessed and read by the public. Welcome to an introduction to object level logging with S3 buckets. In this short lecture, we will explore the powerful capabilities of object level logging and its integration with AWS CloudTrail. Let's start by understanding AWS CloudTrail, a service designed to record and track all AWS API requests made. These requests can be initiated from various sources, including SDKs, the AWS command line interface, the management console, or other AWS services. AWS CloudTrail captures S3 data events such as get object, delete objects, and put objects API calls, and records them within log files stored on S3. You can configure the capturing of these events at the bucket level or through AWS CloudTrail itself. To enable object level logging, you will need to select an existing trial from the same region to capture your S3 data events for the bucket. Then choose the type of events you want to capture, whether read events, write events, or both. By enabling object level logging, AWS CloudTrail will capture any S3 data events associated with the bucket, providing valuable insights into the activities within your S3 buckets. Let's dive into object log property, an advanced feature of an S3 bucket. The object log feature ensures a level of compliance known as warm or write once read many, protecting objects from deletion for a defined period or indefinitely. Objects log can only be enabled at a time of bucket creation, requiring versioning to be enabled first. Two retention modes, governance and compliance, offer different levels of protection against object deletion. Object log can also be set on a per object basis, allowing for specific retention modes and legal holds. Object log provides essential protection for S3 buckets, ensuring compliance with regulations and safeguarding data integrity. Welcome to a quick guide on using cost allocation tags with your S3 buckets. When using Amazon S3 for various business units and departments, managing buckets can be challenging. Cost allocation tags are key value pairs assigned at the bucket level, help with categorization. For example, you can tag buckets with project and environment to organize resources. These tags can be used across all AWS services, allowing you to manage, categorize, and organize your response resources effectively. With the Cost Explorer in AWS Billing and Cost Management, you can report on these key values to understand project costs. To add tags to your bucket, simply select your bucket, go to the Properties tab and select Tags. Configure your tags as required and click Save. Remember to activate your cost allocation tags in AWS Billing before they show up on your any reports. So start organizing your S3 resources effectively with cost allocation tags. Let's dive into how we can speed up the long distance S3 data transfers by using transfer acceleration. Transfer acceleration can significantly speed up the process of transferring data into or out of Amazon S3 from your remote client or to another AWS region. It achieves these by leveraging Amazon CloudFront, a content delivery network service with edge locations worldwide. When you enable transfer acceleration at the bucket level, your data transfer requests are routed through a high-speed optimized AWS network path to Amazon S3 via a CloudFront edge location. These can lead to a dramatic reduction in transfer times. It's important to note that there are costs associated with using transfer acceleration, including a cost per GB depending on the edge location used. Additionally, there are increased costs for any data transferred out of S3 due to the edge location acceleration involved. Enabling transfer acceleration is straightforward. Simply select your bucket within the S3 console, choose Properties, and then select the Transfer Acceleration tile. From there, you can enable or suspend it as needed. So if you are looking to optimize your long distance S3 data transfers, consider leveraging transfer acceleration to speed up the process and improve efficiency. Welcome to a quick guide on the requester pays feature for S3 buckets. The requester pays feature in Amazon S3 shifts the responsibility of request and data transfer cost from the bucket owner to the requester. To enable requester pays, simply select the requester's pays tile from the properties of the required bucket, choose to enable it and save. Remember, all access to the bucket must be authenticated to this feature to work. With requester pays, the costs associated with the request and data transfers are seamlessly transferred to the requester, providing a clear and efficient way to manage expenses. Let's dive into various methods of using policies and permissions to gain access to S3 resources. Identity-based policies are a powerful way to control access to S3 resources. By attaching these policies to IAM identities, users, groups, or roles can be granted specific permissions. These policies define the resources and can even include conditions for further access control. On the other hand, resource-based policies such as bucket policies and access control lists are associated with the resource itself. They allow for more granular control over access to S3 buckets and objects. When deciding between IAM and bucket policies, consider the scale and scope of access control needed. IAM is ideal for centralized management, while bucket policies are great for maintaining security policies within S3 alone. In the event of conflicting permissions, AWS follows the principle of least privilege. Access is denied by default, and explicit deny permissions always take precedence over allow permissions. By understanding these methods, you can effectively manage access to your S3 resources. So welcome to this short lecture on cross-origin resource sharing, also known as CORS in Amazon S3. So CORS allows specific resources on a web page to be requested from a different domain than its own, enabling the development of client-side web applications. To configure CORS for a bucket in Amazon S3, you will need to utilize policies embedded in the CORS configuration of the bucket, which can be found under the Permissions tab. For example, a policy might allow PUT, post and delete from the origin of a specific website, while also determining which headers are allowed in a pre-flight request. When a browser sends a pre-flight request to the S3 bucket, the CORS configuration is evaluated and the first matching rule in the policy is processed based on the requester's origin header, the request method, and the headers used. So your CORS policy can contain more than one rule, each with specific conditions for different origins and methods. If you are dealing with the data lake workload in a versioned S3 bucket that's growing rapidly, managing these data swamp can be costly and challenging. But there are tools available to help you manage the storage lifecycle of your data efficiently. You can automate these processes using two approaches. The first is the S3 Intelligent Tiering Storage class, which monitors object access pattern and automatically moves objects between tiers. The second approach is using lifecycle configurations, which transition data to lower cost storage classes or delete data based on defined access patterns. If your objects and workloads follow predictable usage patterns, using lifecycle configuration is the most cost-effective strategy. For example, you can create a solid lifecycle configuration based on specific access patterns, leading to significant cost saving in your overall storage spend. If your data follows similar access patterns, such as slowly decreasing real-time access or needing to meet compliance regulations, using lifecycle configurations makes sense for your workloads. So in summary, lifecycle configurations are a crucial cost tool that enables you to manage your data efficiently, transitioning objects to lower cost storage tiers and delete unnecessary objects. So let's understand S3 lifecycle configuration. Each configuration contains rules with four components: ID, filters, status, and actions. The ID uniquely identifies the rule, crucial for managing up to 1000 rules in one configuration. The filter section defines which objects in your bucket you would like to take action on, following for granular control. The status field enables you to enable or disable each rule, providing flexibility for testing and managing lifecycle actions. Lastly, the actions section defines where you want your objects to move to, whether transitioning to another storage class or being deleted. Let's explore the Amazon EFS service and its role in the storage ecosystem. Let's start by comparing a few AWS storage solutions. Amazon S3 is ideal for large files like videos and images, while EBS is optimized for low latency access and fast read and write operations. Now let's dive into Amazon EFS. It's a file level storage optimized for low latency access and supports access by multiple EC2 instances at once. This makes it a great option for applications that scale across multiple instances. Amazon EFS is a fully managed, highly available, and durable, allowing you to create shared file systems that can easily scale to petabytes in size with low latency access. It's a desirable storage solution for a wide variety of workloads and use cases. So in conclusion, Amazon EFS is a powerful, scalable, and reliable storage service that can meet the demands of various applications and workloads. Let's dive into the demonstration on creating and mounting an EFS file system in the AWS Management Console. So EFS offers two methods to connect your Linux-based EC2 instance to your EFS file system. The newer method using the EFS mount helper is now the preferred option. This utility simplifies the entire mount process and provides built-in logging capabilities for troubleshooting. So before using the EFS mount helper, ensure that you have created and configured your EFS file system and have an EC2 instance running with the EFS mount helper installed. The instance must be in the VPC, configured to use Amazon DNS servers, and have a security group allowing NFS access to your Linux instance. Now let's move on to creating the EFS file system. Start by configuring the file system access, selecting the VPC and adding the security group for the mount target. Then configure optional settings such as lifecycle management, throughput mode, performance mode, and encryption. Once the EFS file system is created, you can proceed to mount it using the EFS mount helper. Let's dive into short lecture on importing on-premises data into EFS. If you're considering using EFS, you likely have a specific dataset in mind that could benefit from this service. To seamlessly move, migrate, and synchronize data from your on-premises site to AWS storage services like Amazon EFS, the recommended approach is to utilize AWS Data Sync. This service is designed to securely transfer data over a direct connect link on the internet, providing simplicity and ease. To sync source files from your on-premises environment, you will need to download the data sync agent as a VMware ESXi to your site. These agents act as a bridge between your on-premises file system and your EFS file system, making the data transfer process seamless. AWS Data Sync is versatile, allowing you to migrate, replicate, and manage EFS file systems across different AWS regions. For detailed use cases and implementation, AWS has provided an in-cloud quick start and scheduler on GitHub. So in conclusion, AWS Data Sync is a powerful tool for effectively transferring data to and from Amazon EFS, providing flexibility and ease of use for various use cases. Let's cover EC2 instance level storage. So EC2 instance store volumes, also known as instance store volumes, are local disk drives physically residing on the same host as your EC2 instance. They provide ephemeral storage, meaning any data stored on these volumes is considered temporary. While it's not recommended to store critical data on these volumes due to the risk of data loss upon instance stop or termination, they offer benefits such as cost savings, high input-output speeds, and suitability for frequently changing data, or as a cache. Not all instance types supports instance store volumes, and their size increases with the EC2 instance size. From a security perspective, they don't offer additional security features and rely on the security mechanism provided by EC2. If you need persistent data or easy persistency maintenance, the Elastic Block Store service is recommended over EC2 instance store volumes. Let's try understand Amazon Elastic Block Store, also known as EBS. Let's dive into the key features and benefits of these essential AWS service. EBS provides persistent and durable block level storage, offering more flexibility in managing data compared to instance stored volumes. These volumes can be attached to EC2 instances and are ideal for rapidly changing data that may require specific input-output operations per second rate. EBS also offers point-in-time backups known as snapshots stored on Amazon S3, providing resilience and flexibility. Plus, EBS volumes are created with reliability in mind, replicating every write to prevent data loss. There are two types of EBS volumes: SSD-backed storage and HDD-backed storage, each with unique characteristics and performance factors. These volumes cater to different use cases, from database to big data processing. EBS enhances data security through encryption using the AES-256 encryption algorithm and interacting with the key management service. You can create EBS volumes during instance launch or as a standalone volumes with the option to resize them elastically. While EBS offers numerous benefits, it's important to note that it may not be suitable for all storage requirements. For temporary storage or multi-instance access, other AWS services like Amazon S3 or EFS may be suitable. Amazon Data Lifecycle Manager. Let's dive in and explore this essential tool for automating EBS snapshots and AMI backups. Amazon Data Lifecycle Manager is a powerful tool that automates the creation, deletion, and retention of EBS snapshots and EBS-backed AMIs. It's like having backups for your EBS data without the hassle of manual intervention. DLM is provided at no extra cost and can be used in conjunction with other AWS services like Amazon CloudWatch Events and AWS CloudTrail, providing a complete backup solution for your EC2 instances. It's important to note that EBS volumes and snapshots will incur cost based on their size and use. Additionally, proper tagging of resources is crucial for DLM to function effectively. With Amazon DLM, you can streamline and automate your backup process, ensuring the safety and security of your EBS data. Let's compare Amazon FSx for Windows File Server and Amazon FSx for Lustre. So Amazon FSx for Windows File Server provides a fully managed native Microsoft Windows file system on AWS. It's built upon Windows Server, operates as shared file storage, and offers full support for SMB protocol, Windows NTFS, Active Directory integration, and distributed file system. Plus, it uses SSD storage for enhanced performance and throughput, providing sub-milliseconds latencies. On the other hand, Amazon FSx for Lustre is designed for compute-intensive workloads such as machine learning and high-performance computing. It offers massive data processing capabilities with performance running to hundreds of GB per second of throughput, millions of IOPS and sub-milliseconds latencies. The pricing for each option operates differently. Amazon FSx for Windows File Server has pricing based on capacity, throughput, and backups, while Amazon FSx for Lustre offers a simpler cost model based on the storage capacity used. Depending on your workload and use case for your data, you will choose either Windows Server or Lustre. The Windows Server option offers more flexibility from a pricing point of view, with the added advantage of data deduplication to help save up to 80% of storage cost. Although it does also have a cost associated with throughput capacity, which Amazon Lustre does not. So let's try and understand AWS Storage Gateway, a powerful tool for integrating your on-premises storage with Amazon S3 and Glacier. File gateways allow you to securely store your files as objects within S3, providing a type of file share for your corporate network. This setup includes a local on-premise cache for optimized latency and reduced egress traffic costs. Volume gateways offer two configurations, stored and cached. Stored volume gateway backup local storage volumes to Amazon S3 as EBS snapshots, while cached volume gateways primarily store data on S3 with local storage as a buffer. Tape gateways or gateway VTL enable data backup to S3 and leverage Glacier for data archiving at a lower cost. The pricing for tape gateway is split across storage and request pricing, with different options for storage pricing, including S3, S3 Glacier, and S3 Glacier Tape Archive. AWS Storage Gateway provides a range of storage options, each with its own pricing structure. Whether you need file, volume, or tape gateways, the service offers a cost-effective solution tailored to your specific needs. So let's try and understand AWS Backup, a powerful solution for managing and implementing backups across various AWS services. AWS Backup acts as a central hub to manage backups across your environment, providing full auditability and compliance controls. It also allows for the automation of on-premises data backup through its connectivity with the AWS Storage Gateway service. When using AWS Backup, you will need to create backup plans, which include backup schedules, windows, lifecycle rules, backup vaults, regional copies, and tags. These plans allow you to assign resources and create multiple backup plans to meet the needs of different resource types. For cost optimization, AWS Backup supports warm and cold storage, with data transitioned between the two via lifecycle rules. Warm storage is backed by Amazon S3, while cold storage is backed by the Glacier storage class, offering a lower price point per GB month. AWS Backup provides a centralized, comprehensive view of backups, allowing for different requirements for various resources and implementation of life cycle rules for cost optimization. Be mindful for the pricing for backup storage and data restoration, and implement life cycle rules to maximize cost benefits. So let's dive into the fascinating world of the AWS Snow family. The Snow family consists of a range of physical hardware devices designed to facilitate data transfer into and out of AWS. Unlike typical cloud interactions, these devices provide a unique solution for transferring data outside of AWS, involving the use of physical hardware packed with storage and compute capabilities. From the compact AWS Snow Cone to the colossal AWS Snowmobile, the Snow family covers a wide range of data transfer needs, from just a few terabytes to a staggering 100 petabytes. This is especially crucial when traditional network connectivity is not feasible due to time constraints and cost implications. In addition to storage capacity, some devices in the Snow family also offer compute power, enabling the operation of EC2 instances in remote and challenging environments. For example, the Snow Cone can be equipped with battery packs, enhancing its versatility and enabling the processing and analyzing of data closer to the source. So let's do a AWS Node device comparison and use cases. Let's explore the unique features and ideal use cases for AWS Snowcone, AWS Snowball, and AWS Snowmobile. The AWS Snowcone is the smallest and most portable of the Snow family, designed for lightweight, rugged use, with 8 terabytes of storage and an EC2 instance. It's perfect for capturing, processing, and analyzing data even in remote locations. It's ideal for IoT sensors data capture and can be used with AWS Data Sync for online data transfer. The AWS Snowball, available in storage, compute, and GPU optimized options, is suitable for large scale data transfer operations of up to 80 terabyte at a time. It's great for data migrations, compute intensive workloads, and video analysis. The Snow Cone is best for portable, on-the-go needs, while the Snowball is ideal for larger data transfers, enhanced graphics, processing, and specific storage and network requirements. Both the snow cone and snowball are perfect for portable edge computing, data collection in remote locations, and use in the media and entertainment industry. The AWS Snow Mobile is designed for massive data transfers for up to 100 petabytes per snowmobile, making it ideal for migrating entire data centers or storage libraries. Now that we have explored the unique features and use cases for each AWS Snow device, you can make an informed decision based on your specific data transfer needs. Both the snow cone and snowball devices automatically encrypt transferred data backed by keys generated by the key management service. Their enclosures are anti-tampered and undergo specific verification checks to ensure data integrity. These rugged devices are windproof, dustproof, water resistant, and can withstand operational vibrations and shocks. The devices use e-ink shipping labels for tracking and are equipped with secure erase capabilities to meet NIST standards for data sanitization. The Snowmobile, on the other hand, comes with a connector rack and up to 2 km of network cabling. It operates within ambient temperatures up to 85 Fahrenheit and is backed by robust security measures including encryption, GPS tracking, and 24 by 7 video surveillance. These devices offer cutting-edge solutions for secure and efficient data transfer, catering to a wide range of environmental and security requirements. If you have been working with different AWS storage services, you may have come across AWS Data Sync. It's a service that allows you to easily and securely transfer data from your on-premises data center to AWS storage services. It can also manage data transfer between different AWS storage services, making it great for migration management and data movement. AWS Data Sync supports working with data stored on network file system shares, server message block shares, and self-managed object storage. In addition to various AWS services like Amazon S3, Amazon Elastic File System, Amazon FSx for Windows File Server, and AWS Snowcone. It utilizes AWS VPC endpoints for high bandwidth, low latency data transfer and comes with a purpose-built data transfer network protocol for rapid data transfer. To address security concerns, AWS Data Sync provides end-to-end security through encryption in transit using the transport layer security protocol and encryption at rest mechanisms. It also ensures data validation to confirm that data arrives at its destination intact and unaltered. From a cost perspective, AWS Data Sync uses a flat pricing strategy based on a per gigabyte of data transferred, making it easy to predict and avoid unexpected costs. If you have been running your own on-premises storage services for a while, AWS Data Sync can help you migrate data from your data center into Amazon S3 Glacier storage classes like Glacier Deep Archive for a more cost-effective and durable storage solution. These can also help you remove any old or legacy storage solutions you may have been using. Another scenario where AWS Data Sync comes in handy is for steady and active data migrations to Amazon S3, Amazon FSx for Windows File Server or EFS. These can be useful for backup purposes or disaster recovery, such as migrating data to EFS for a standby file system in the cloud in case of an outage. Lastly, if you're working with a hybrid cloud solution, AWS Data Sync can help you harness the power and speed of AWS services for tasks like machine learning and data processing. You can migrate the data into AWS for additional processing and analysis, and then migrate the results back into your data center when operations are completed. Let's dive into the architecture of the service and the different component levels in carrying out a data sync task. When transferring data from your own managed storage environment to AWS, you will need to configure an agent, a location, and a task. The agent, a virtual machine, is used to read and write data to your storage solution. The location identifies the endpoint of a data sync task, specifying the source and destination locations. The task contains the details of the operation, including the configuration and conditions of the data transfer. When transferring data between two different AWS storage services, such as Amazon S3 to Amazon EFS, the process is similar but without the use of the agent. Two locations and a task are created to carry out the data transfer. AWS Data Sync efficiently moves your storage data, ensuring a seamless transfer process. Let's dive into the world of VPCs or virtual private clouds within the AWS infrastructure. A VPC is essentially your own isolated segment of the AWS cloud, providing a secure environment for deploying resources like compute, storage, databases, and network infrastructure. When you create a VPC, it's completely isolated, accessible only by your own AWS account. Each customer has their own VPC with no access to others. There's a limit of 5 VPCs per region per AWS account. Creating a VPC is straightforward. Just give it a name and define an IP address range using a CIDR block. In summary, a VPC is a secure segment of the AWS public cloud, allowing safe and secure resource deployment. Let's talk about managing security in AWS Virtual Private Cloud, VPC. Firstly, let's dive into NACLs, which are like virtual network level firewalls for your subnets. By configuring NACLs, you can control both ingress and egress traffic moving in and out of your VPC and between your subnets. For example, you can set rules to allow only HTTP and HTTPS traffic into your public subnet, ensuring the security of your web servers. Now let's shift your focus to security groups. Unlike NACLs, security groups work at instance level, providing another method of controlling traffic within your VPC. In conclusion, both NACLs and security groups are essential tools for managing security within your AWS Virtual Private Cloud. So let's dive into AWS security groups. These are a crucial part of managing your AWS infrastructure, so let's break it down. Security groups in AWS are like network access controllers, but they work at the instance level, not the subnet level like NACLs. They filter both inbound and outbound traffic, allowing you to control access to your instances. For example, you can use security groups to restrict access to specific instances, like allowing access to RDS and Aurora databases from one subnet while denying access from another. This level of control ensures a secure environment for your data. By working in tandem with NACLs, security groups provide layered protection. NACLs control traffic at the subnet and network layer, while security groups manage access at the instance layer. Unlike NACLs, security groups are stateful, meaning you don't need to configure specific rules to allow return traffic from requests. This simplifies the management of your AWS security. So when it comes to securing your AWS infrastructure, understanding security groups is key. They provide granular control over your instances, ensuring a robust and secure environment. Let's dive into understanding the NAT gateway in AWS VPC. In an AWS VPC, a NAT gateway allows instances within a private subnet to access the internet while blocking all incoming initiations from the internet. It's a crucial component for maintaining the security of your EC2 instances and ensuring their operating systems are kept up to date. The NAT gateway sits within the public subnet, has a public IP address, and is managed by AWS. It's easy to set up. Simply create the NAT gateway, simplify the subnet, and associate an elastic IP address. AWS will handle the rest, including setting up multiple NAT gateways for resiliency. If you have multiple public subnets in different availability zones, you will need to set up another NAT gateway within each subnet. AWS won't automatically deploy a NAT gateway within each public subnet. So a NAT gateway is a powerful tool for providing private subnets with internet access while maintaining security. It's a key part for keeping your AWS deployment secure and up to date. Now let's talk about Bastion host in AWS. Imagine you have EC2 instances in a private subnet and you need to access them from outside the network. You can do that. Well, that's where a Bastion host comes in. In this scenario, the Bastion host sits in the public subnet and acts as a secure gateway. It allows an engineer to connect from their home office to the EC2 instance in a private subnet. The engineer first connects to the Bastion host using SSH and then uses it as a jump server to access the private instances. To ensure security, the Bastion host security groups is configured to allow SSH access only from the engineer's IP address. Additionally, SSH agent forwarding is used to store private keys on the engineer's local client rather than the on-Bastion host. To summarize, the process involves setting up a Bastion host in the public subnet, hardening its security, configuring security groups, and using SSH agent forwarding for secure access to the private instances. Understanding Bastion host is crucial for secure remote access to resources in AWS. Now let's talk about using VPN connections with AWS VPC. A virtual private network is a secure way of connecting two remote networks across the internet. In our scenario, we have a VPC in AWS and a remote data center. We want to enable secure communications between the resources in our private subnet in AWS and the resources in our data center. To do this, we can create a VPN connection. These involve setting up a virtual gateway in the VPC and a customer gateway in the data center, initiating a tunnel between the two endpoints, and configuring route tables and security groups. This creates a secure connection across the internet, allowing traffic to flow between the two locations. Now let's talk about direct connect. This method of connecting your remote location to your AWS environment does not doesn't use the internet. Instead, it uses private infrastructure and connects directly to your VPC. It involves a middle entity, usually an AWS partner or customer, and allows access to both private and public resources within an AWS region. This provides a secure and direct connection without traversing the public network. So, have you ever wondered how to connect two VPCs together? Let's talk about VPC peering. VPC peering allows you to connect two VPCs together, enabling them to communicate with each other, even if they are in different regions. It's a one-to-one connection only, so each VPC needs a separate peering connection. VPCs cannot have overlapping IP addresses for the connection to work. The process involves a requester and an acceptor, with routing tables updates to allow traffic between the VPCs. VPC peering is a powerful way to exchange information and enable communication between VPCs. So are you struggling with managing multiple VPCs and connections from remote locations? Let's talk about the AWS Transit Gateway and how it simplifies network connectivity. In today's world, managing multiple VPCs and connections from remote locations can be cumbersome and time consuming. Creating VPCs peering connections from each one-on-one connection is just not very well to manage. The AWS Transit Gateway allows you to connect all your VPCs and remote connections via a central hub, simplifying your entire network connectivity. All routing is managed centrally within the hub, making it easy to communicate with one another. This centralized approach streamlines network monitoring and allows for easy scalability. With the Transit Gateway, new VPCs can seamlessly communicate with the entire infrastructure. In summary, the AWS Transit Gateway simplifies network connectivity, making it easier to manage multiple VPCs and connections from remote locations. Let's dive into the world of elastic IP addresses, also known as EIPs. When launching an EC2 instance, you can select the subnet it resides in and choosing to auto-assign a public IP address. However, if you need a persistent public IP address, and an elastic IP address is the solution. It's associated with your account, allowing you to attach it to an instance or an elastic network interface. EIPs remain in place even if the associated instance is stopped, and you can detach or reattach them as needed. However, do keep in mind that detaching an EIP when it's not associated with the running instance will incur a cost. Let's quickly dive into Elastic Network Interfaces, also known as ENIs. ENIs are logical virtual network cards within your virtual private cloud, your VPC, that you can create, configure, and attach to your EC2 instances. The configuration is bound to the ENI and not the instance that it is attached to. This means that you can also detach your ENI from one instance and reconnect it to another instance, and the configuration of the ENI would move with it. There will be occasions where you will need your instances to have multiple network interfaces. For example, if you wanted to create a management network, and in these instances, you can create and use an ENI to attach to your instance in addition to its primary interface of ETHO, capturing traffic and quantity of interferences. All traffic originating from and being sent to an ENI can be captured using VPC flow logs. When designing your solution and any requirements for multiple interfaces being attached to your instances, you will need to bear in mind that the quantity of interfaces is dependent on the EC2 instance type. ENIs provide flexibility and scalability for managing network interfaces within your VPC. So next time you need to create and configure network interfaces for your EC2 instances, consider using ENIs for a seamless and efficient solution. Now let's understand VPC endpoints. VPC endpoints come in two types: interface endpoints and gateway endpoints. Interface endpoints are especially ENIs placed within a subnet, while gateway endpoints are targets used within route tables to reach supported services like Amazon S3 and DynamoDB. Interface endpoints operate through private link, allowing a private and secure connection between VPCs, AWS services, and on-premises applications. When configured, the service associated with an interface endpoint cannot initiate a connection to your VPC. Instead, communication must originate from within your VPC burst. When an interface endpoint is created for a service, a specific DNS host name is associated with private hosted zone in your VPC. This means that any applications using that service do not need to be reconfigured. Request to that service using the default DNS name will now be resolved to the private IP addresses of the interface endpoint and will route through the internal AWS network instead of the internet. Gateway endpoints are used within route tables to reach supported services like Amazon S3 and DynamoDB. During creation, you can select which route tables within your VPC should be updated to add the new target of the gateway endpoint. Understanding VPC endpoints is crucial for leveraging the full potential of AWS services. So let's dive into the world of AWS Private Link. AWS Private Link is an AWS capability that enables service providers to create and offer endpoint services to their consumers privately and securely using the AWS global network. It involves two entities, service providers and service consumers. AWS Private Link has three primary use cases. First, it allows customer to access services provided by private link service providers without requiring any public internet connectivity. Second, it can be used to maintain regulatory compliance by keeping sensitive data from traversing the public internet. And third, it enables on-premises resources to connect to AWS service endpoints over an AWS Direct Connect or VPN. So whether it's for secure data access, regulatory compliance, or hybrid cloud migrations, AWS Private Link offers a powerful solution for private and secure connectivity. Amazon CloudFront and its key features. Let's dive in and explore its purpose and the main features that make it an essential tool for content distribution. Amazon CloudFront plays a crucial role in caching content, allowing us to store our content closer to the users who need it. By caching content on edge locations, CloudFront significantly reduces latency for end users, providing a faster and more efficient content delivery experience. CloudFront works seamlessly with both static and dynamic content, making it a versatile solution for various content types. It also offers a wide range of configuration options, including catchy times to lives, custom headers, and alternate domain names, providing flexibility and customization for content delivery. With its global network of edge locations, Amazon CloudFront ensures low latency and high speed content distribution, making it an indispensable tool for businesses looking to enhance their content delivery capabilities. So if you're looking to optimize your website's performance and security, let's explore two powerful examples of using CloudFront to catchy and secure access to your content. Imagine seamlessly integrating CloudFront with an application load balancer to enhance your website security and performance by configuring CloudFront to add custom HTTP headers and securing connections to the load balancer. You can ensure that all traffic is routed through CloudFront, providing an additional layer of protection. Now picture leveraging CloudFront to catchy and secure content stored in an S3 bucket. By creating a CloudFront distribution with an alternate domain name and a certificate, you can enable HTTPS and globally distributed your content, reducing latency for your users. Whether you're using an application load balancer or an S3 bucket, CloudFront offers a robust solution to optimize your website performance and security. Ready to take your website to the next level? Consider implementing CloudFront. Welcome to the AWS Global Accelerator overview. We'll explore the key features and setup process for an AWS Global Accelerator. The AWS Global Accelerator is designed to optimize UDP and TCP traffic, ensuring faster, more reliable connections for your end users. By leveraging AWS global infrastructure and specified endpoints, it provides a secure and efficient alternative to traversing the public internet. To set up the AWS Global Accelerator, follow these four simple steps. Create your accelerator and select IP addresses. Then create a listener to process incoming connections. Next, associate the listener with an endpoint group configuring traffic dials and health checks. Finally, associate and register your endpoints for your applications such as load balancers or EC2 instances. With the AWS Global Accelerator, you can enhance the performance and availability of your application across different regions. Try it out today and experience the benefits of a faster, more reliable network infrastructure. Welcome to the introduction to Amazon Route 53. So let's discover the powerful features and capabilities of Amazon Route 53, a service that goes beyond domain name registration and management. Amazon Route 53 offers domain name registration, DNS management, and traffic management. It implements traffic routing, health checks, and routing policies, including failover and latency routing. The traffic flow features allows for complex routing configurations, and the application recovery controller manages failovers with integrated health checks. Route 53 uses edge locations in the AWS global infrastructure, providing 100% available SLA. It's a global service, eliminating the need to specify a region in configuring Route 53 resources. The Amazon Route 53 resolver service integrates easily with DNS in your data center, while the resolver DNS firewall is a managed service for DNS queries originated in your VPC. With Amazon Route 53, you gain a comprehensive domain name management service with global traffic control capabilities. So get ready to explore the world of Amazon Route 53 and take your domain managed to the next level. Have you ever wondered how the internet knows where to send your request? It's all thanks to Amazon Route 53, the domain name management service provided by AWS. Route 53 is like a phone book for the internet, translating domain names to IP addresses every time we use the internet. It's an essential part of the internet's infrastructure. When you use Amazon Route 53 to register a domain, it creates a public hosted zone, defining how traffic is routed on the public internet. Private zones define how traffic is routed inside a virtual private cloud. Route 53 supports common record types like AAA, MX, TXT, and CNAME records, each servicing a specific purpose in mapping host names to IP addresses and providing information to systems outside of your domain. So the next time you type in a website name, remember that Amazon Route 53 is working behind the scenes to make sure you reach the right destination. Now let's look into Amazon Route 53 health checks. Amazon Route 53 health checks are independent resources used by most routing policies. They send requests to the endpoint every 30 seconds, determining if it's healthy or unhealthy. You can configure health checks for different tiers of your application and monitor the state of a CloudWatch alarm. Route 53 adds up the number of healthy checks and compares it to the health threshold value. When Route 53 receives a query, it chooses a record based on the routing policy and responds with the value of a healthy record. Unhealthy records are not considered. You can customize the list of health checkers by region and specify health checks by IP addresses or domain name. The protocol can be TCP, HTTP, or HTTPS with optimal string matching for HTTP related protocols. You can choose to get notified when a health check fails. So have you ever wondered how DNS queries are answered? Well, the routing policy for a record defines just that. Let's dive into the different types of routing policies and what they do. The simple routing policy provides the IP addresses associated with the name. It's important to note that simple routing policies do not support health checks. All other routing policies do. Similar to simple routing, a weighted routing policy allows you to define a weight per IP address. This is useful for load distribution on testing new software. The geolocation routing policy tags records with a location that can be default, continent, or country. It allows you to distribute the IP of a resource based on the customer's location. The geo-proximity routing policy is based on distance and a defined bias. It allows you to shift traffic from one location to another and route traffic based on the location of your resources. The failure routing policy is able to route traffic to a primary resource and redirect traffic to a secondary resource if the health check fails. Let's try simplify record management with traffic flow. The traffic flow visual editor allows you to create and visualize complex sets of records combining multiple routing policies and health checks in a single configuration. Traffic flow automatically creates hundreds of records when you create a policy record associating traffic policies with domain or subdomain name records. If you are looking to seamlessly integrate your data center DNS with AWS, let me introduce you to Route 53 Resolver, the DNS service designed specially for VPCs that integrates with your data center. To get started, you will need to establish connectivity between your data center DNS and AWS using a direct connect or a virtual private network connection. These ensures a smooth integration process. Once connected, you can configure endpoints for DNS queries into and out of VPCs. These endpoints are set up through IP address assignment in each subnet requires the Route 53 resolver. And don't forget about the Route 53 resolver DNS firewall, a managed service that inspects and filters traffic originated in your VPCs. With customizable rules, you can control how DNS queries are handled and protect your VPCs effectively. So if you are ready to streamline your DNS integration, the Route 53 resolver is the solution you have been looking for. Now let's dive into Amazon Route 53 Application Recovery Controller. Amazon Route 53 Application Recovery Controller continuously monitors an application ability to recover from failures and controls application recovery across multiple availability zones, regions, and data center environments. You can define readiness checks to monitor AWS resources configurations, capacity, and network routing policies, ensuring that the recovery environment is scaled and configured to take over when needed. Routing controls work with readiness checks to failovers an entire application based on custom conditions like applications, metrics, partial failures, increased error rates, or latency. They also allow for manual failover and traffic shifting for maintenance purposes or during a real failure scenario. Amazon Route 53 Application Recovery Controller provides a way to configure fine-grained failover and verification steps implementing applications requiring very high availability. So welcome to this overview of Amazon Relational Database Service RDS, a managed service within AWS that simplifies the provisioning, creation and scaling of relational databases with RDS. Mundane administrative tasks like backups and patching are managed by AWS, allowing you to focus on your applications. Amazon RDS offers a variety of database engines options including MySQL, MariaDB, PostgreSQL, Amazon Aurora, Oracle, and SQL Server. Each engine is tailored to a specific needs from open source preferences to corporate environments. Now let's understand the features and options available in Amazon RDS. Let's dive into the key aspects you need to know. So when creating your RDS database, you have to select an instance to support your database from a processing and memory perspective. Plus consider multi-AZ for high availability and resiliency. Optimize your RDS database to meet the demands of your load with features like storage, auto-scaling, and scaling your compute size both vertically and horizontally. Amazon RDS take care of administrative tasks like patching and automated backup, providing an automatic backup feature and the ability to perform manual backup anytime you need to. So understand these features and options will make you the most of Amazon RDS for your database needs. So if you're trying to decide between Amazon RDS and EC2 for your relational database deployments in AWS, let's explore the benefits of each approach to help you make an informed decision. Amazon RDS or the Amazon Relational Database Service is an AWS managed service that simplifies the process of installing and provisioning relational databases in AWS Cloud. It supports popular open source and commercial database engines including MySQL, MariaDB, PostgreSQL, and even Oracle and Microsoft SQL Server. RDS also offers Amazon Aurora, a highly high performance, cost effective database solution. So RDS allows you to quickly spin up a new database without the need to install or configure any operating system or database software. AWS take care of administrative tasks such as backup, security, and high availability, making it ideal for smaller development shops or organizations without a dedicated database administrator. So in conclusion, Amazon RDS offers simplicity, cost effectiveness, and managed services, making it a compelling choice for many use cases. Now let's dive into various purchasing options available for database instances and associated costs. So you can purchase database instances to different payment plans, such as on-demand instances, reserved instances, and serverless. Each option is designed to help you save cost by selecting the most appropriate one for your deployment. Currently, only the Oracle database engine uses BYOL purchase options, while other DB engines utilize on-demand instances and reserved instances. Aurora also offers serverless as an additional purchasing option. So understanding these options can help you save a considerable amount of money based on your specific use case. So let's start by exploring on-demand instances which can be launched at any time and provisioned within minutes. So the cost of the compute capacity is calculated hourly on no minimum usage term. So the larger and the powerful the instance, the higher the cost. Any partial dB instance hours used are cost on per second increments. So it's essential to select the appropriate instance to support your database from a processing and memory perspective, as these will impact the instance price. So if you're trying to deploy your RDS database in AWS, let's explore the various options available. So you can choose to deploy your RDS database within a single availability zone or opt for a multi-AZ deployment to ensure high availability. Keep in mind a multi-AZ deployment will incur additional cost for a standby instance in another availability zone. If you are considering Amazon Aurora as your DB engine, you have the choice between Amazon Aurora with MySQL compatibility or Amazon Aurora with PostgreSQL compatibility, each with different pricing for on-demand instances. So another integrating option is Amazon Aurora Serverless, which eliminates the need to manage instance. Pricing is based on Aurora capacity units with each ACU charged at $0.07 per ACU hours in the London region. Consider the bring your own license option for Oracle, which allows you to use your pre-existing license. Additionally, reserved instances offer significant cost savings with reductions of up to 75% compared to on-demand instances. So with a range of deployment option and cost saving strategies, deploying your RDS database in AWS can be tailored to your specific needs. Now let's dive in and explore the different options available about Amazon RDS storage types and pricing. Amazon RDS supports three main storage types, including general purpose SSD storage. This option is ideal for a wide range of use cases, offering low latencies and cost-effective solution with a minimum storage of 20 gigabytes and a maximum of 64 terabytes for most DB engines. It's a versatile choice. So for workloads with high input-output operations, provisioned IOPS SSD storage is a great fit. You can provision a minimum of 8,000 IOPS and a maximum of 80,000 for most DB engines. The charges are based on the provisioned storage and IOPS throughput, ensuring flexibility for your specific workloads. Magnetic storage is mainly for backward compatibility, and AWS recommend selecting general purpose SSD instead. It's a simple and straightforward option for a specific use cases. So understanding the different RDS storage types and pricing can help you make informed decisions for your database needs. Whether it's general purpose SSD, provisioned IOPS, or magnetic storage, Amazon RDS offers a versatile solution tailored to your requirements. Now let's understand the cost of database backups. So when it comes to the backup storage cost for your database, there are few key points to consider. Firstly, Amazon RDS does not charge for backup storage that equates to the total sum of provisioned storage used within a specific region. Any storage used over these free tier is charged at $0.10 per gigabyte month for MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server. For Aurora, the charge is different based on the region. Additionally, both automated backups and manual snapshots will use backup storage, and extended your backup retention periods will increase the storage required. It's important to note that backup storage is calculated based on the total amount of backups storage consumed within a specific region across all your RDS databases. If you copy your backup to another region, these will also increase the amount of backup storage used within the new region. Overall, backup storage for your RDS database is relatively simple to calculate and inexpensive, especially considering it is a free to backup 100% of your provisioned database storage. Now let's dive into the world of Amazon Aurora and Backtrack storage cost. Backtrack is a unique feature available for MySQL compatible Aurora databases, allowing you to go back in time on the database to recover from errors or incidents without the need for a full restore. During the database creation process, you can enable Backtrack via a simple checkbox and simplify the number of hours you would like to backtrack to, with a maximum of 72 hours. The number of changes made directly impacts the cost of the backtrack feature. So for example, if you set 12-hour backtrack and your database generates 50,000 change records per hour, the total cost can be calculated based on the number of change records. So using the London region as an example, the cost would be $0.0084 per hour. To keep track of the number of change records, Amazon CloudWatch can help you monitor the changes generated each hour. So with the Amazon Aurora Backtrack feature, you have the power to recover from incidents with ease while keeping an eye on the associated costs. So if you're looking to perform in-depth analysis of your database data using specialized tools like Amazon Athena, exporting snapshots from your Amazon RDS to Amazon S3 might be a solution you need. Snapshots in RDS are essential backups of your database tables and instances. By exporting these snapshots to Amazon S3, you can leverage services like Amazon Athena, Amazon SageMaker, and Amazon EMR for detailed data and data analysis using standard SQL. When exporting a snapshot, you have the flexibility to filter and export specific databases, tables, or schemas. Keep in mind the cost of performing snapshot exports varies based on the region and the database type. So if you're ready to unlock full potential of your database data, consider exporting snapshot from Amazon RDS to Amazon S3 for a comprehensive analysis. Let's dive into the details of the different data paths where you might be charged for transferring data in and out of your RDS database. When it comes to data transfer, there are various scenarios where you might be charged. For instance, data transferred in and out of your RDS database from the internet to Amazon CloudFront or to different AWS regions. However, there are instances where you won't be charged for data transfer. These includes data transferred in from the internet out to Amazon CloudFront and to EC2 instances in the same availability zone. Data transfer out from your RDS database to the internet is charged per GB, with the first GB each month being free. The pricing is tied, becoming cheaper per GB as the amount of data transferred increases. Additionally, when copying snapshots across regions, you are charged based on the size of the snapshot at a rate of $0.0 per GB. Understanding the intricacies of data transfer cost is crucial for managing your RDS database efficiently. Stay informed to optimize your data transfer expenses. So in this part, we are diving into the key features and characteristics of DynamoDB, a highly talked about database. Let's explore what makes it stand out. So DynamoDB is designed to be highly available by default, with data automatically replicated across 3 different availability zones within a geographic region. This ensures resiliency even in the case of an outage or incident, affecting an entire hosting facility. The database is also infinitely scalable and fast, supporting both eventual consistency and strong consistency based on your specific workload. This means you can choose whether you would prefer to use strong or eventual consistency with every read request to your database. However, DynamoDB supports transactions, ensuring atomicity, consistency, isolation, and durability. This is crucial for use cases like banking, where the reliability of operations is paramount. So whether it's a high availability, scalability, or support for transaction, DynamoDB offers a robust set of features that cater to a wide range of dataset database needs. Now let's dive into some key features and use cases. So to enhance your DynamoDB resiliency and performance. So DynamoDB offers global tables, allowing you to replicate data across regions for high resiliency and low latency access. With active replicas, you can write to any data table and read from the closest one. Perfect for multi-location use cases. DynamoDB provides on-demand backups for compliance and archiving, along with point-in-time recovery for going back to a specific database state. It also integrates with AWS Backup for centralized backup management. DynamoDB is infinitely scalable and fast, making it ideal for OLTP workloads, especially in serverless applications. It's commonly used in gaming, e-commerce, and transportation industries for various data storage needs. Whether it's for gaming, e-commerce, or transportation, DynamoDB is the to-go choice for a fully managed, infinitely scalable, and serverless OLTP database. So let's dive into a key differences between DynamoDB and relational databases. So relational databases scale vertically while DynamoDB scales horizontally, allowing it to scale almost infinitely. This means that DynamoDB scales transparently to the user, handling storage and compute scaling for you. So relational databases have a fixed schema, whereas DynamoDB is schemaless, allowing you to adjust columns and data types on the fly without defining a fixed table structure in advance. DynamoDB's built-in query and scan features aren't as flexible as SQL, but it does not support particular a SQL-like language for querying and modifying data. Additionally, DynamoDB has a limited range of data types compared to relational databases. So if you're already familiar with NoSQL databases like MongoDB, DynamoDB might feel more at home, but it's important to note that NoSQL databases vary within their own category. So DynamoDB has a strict limitation such as a maximum item size of 400 kilobytes, which may require storing large objects in a separate storage solutions like Amazon S3. If you're wondering how to interact with your DynamoDB table, there are four main ways to do. So let's dive into that details. So you can manage your DynamoDB tables through the AWS console where you can view, add and modify data with a graphical interface. Alternatively, you can script API calls using the AWS command line interface, providing a more hands-on approach. For a more customized approach, you can write code using the AWS SDKs available for various programming languages. Lastly, the NoSQL Workbench for DynamoDB offers a visual IDE tool for creating, managing, and querying your tables. So each method allows you to access the DynamoDB API organized as a set of operations for managing and manipulating your tables. Now let's dive into an overview of DynamoDB and DAX. So Amazon DynamoDB is a fully managed NoSQL database service. It's designed to be highly available, fast, and scalable. So with DynamoDB, you don't have to worry about the database administration or managing servers. So now let's talk about the DynamoDB Accelerator or DAX. So DAX is an in-memory cache that significantly enhances performance, offering response times in microseconds. So DAX is highly scalable, capable of handling millions of requests per second. It also reduces the provisioned read capacity within DynamoDB, ultimately reducing overall costs. From a security perspective, DAX supports encryption at rest and seamlessly integrates with your existing architecture without any redesign effort. So in summary, DAX provides extreme performance, scalability, and cost reduction, making it a powerful addition to DynamoDB. So introducing caching. So caching is a high-speed access data layer that stores frequently accessed data sets in memory, providing faster access velocity compared to traditional databases, queries, or disk access. So implementing a caching solution can significantly improve application performance, resiliency, and scalability, delivering at least 50 times faster access than disk access, reducing latencies from milliseconds to microseconds. So caching is crucial for read heavy workloads in social media, gaming, media sharing, news sites, and high performance computing, wherein memory access is essential for high speed data retrievals. Now let's discover the power of Amazon Elastic Cache, a web service designed to simplify the development and operation of an in-memory cache. It seamlessly integrates with Amazon EC2, Amazon RDS, CloudFormation, Elastic Beanstalk, and AWS OpsWorks, providing detailed monitoring metrics through Amazon CloudWatch. So by creating an in-memory data layer between applications and data stores, Amazon Elastic Cache accelerates read operation performance. It supports both mem-cached and Redis key value in-memory engines, offering a significant amount of automation for common administrative tasks. So while memcached is multi-threaded and designed as a caching solution without persistence, Redis supports complex datasets and includes disk persistency features. Elastic Cache for Redis also supports role-based access control and encryption, making it suitable for compliance standards like PCI DSS, HIPAA, and FedRAMP. So Elastic Cache allows for the scaling in and out of nodes similar to EC2 autoscaling and includes auto discovery for new nodes and automatic node replacements in the event of a failure. This feature is applicable to memcached while Redis can be deployed in a multi-AZ configuration with automatic failover. So Amazon Elastic Cache offers a powerful automated solution for managing in-memory caches, supporting both mem-cached and Redis engines with distinct features and benefits. So now let's dive into Amazon Neptune, the fast, reliable, secure, and fully managed graph database service. So the graph databases are designed to store and navigate relationships between highly connected data, making them ideal for identifying complex relationships of interconnected data. Amazon Neptune is recommended for scenarios like social networking, fraud detection, and recommendation engines where querying complex relationships is vital. So Amazon Neptune uses its own graph database engine and supports two graph query frameworks, Apache Tinkerpop Kremlin and World Wide Web Consortium SPARQL. An Amazon Neptune database cluster consists of single or multiple databases instances across different availability zones with a virtual database cluster volume containing the data. So each cluster maintains a separate copy of the shared volume in at least three different availability zones, ensuring high durability and reliability of data. So there are three types of Amazon Neptune endpoints: cluster endpoint, reader endpoint, and instance endpoint, each serving different purpose for connecting to the database. So welcome to a quick guide on understanding Amazon Redshift. So Amazon Redshift is a fast, fully managed petabyte scale data warehouse designed for high performance analysis of information. It's capable of storing and processing petabytes of data and provide access to these data using standard SQL. So a data warehouse consolidates data from multiple sources, allowing you to run business intelligence tools across your data to identify actionable business information. The need for performing an extract, transform, and load ETL job is crucial for combining data from multiple systems into a single database data store or a warehouse for storage or analytics. So Amazon Redshift is built upon clusters and nodes, with each cluster running its own Redshift engine and containing at least one database. The leader node coordinates communication between compute nodes and external applications. So Amazon Redshift boosts industry standard open database connectivity, Java database connectivity drivers for PostgreSQL, and is three times faster than other cloud data warehouses. Amazon Redshift offers features like massively parallel processing, columnar data storage, result caching, and integration with Amazon CloudWatch for monitoring performance. So now, welcome to Amazon Document DB lecture, where we will explore the features and architecture of these powerful database service. Amazon Document DB is a non-relational, fully managed service that highly scalable and fast. It's a document database allowing you to store JSON-like document data and query and index it easily. So this service allows you to scale both compute and storage separately, automatically increasing storage by 10G as your database grows up to a maximum of 64 TB. Amazon Document DB is fully compatible with MongoDB, making it easy to migrate existing databases using the database migration service without modifying your code or toolsets. The architecture of Amazon Document DB is similar to Amazon Neptune with a core cluster component and up to 16 DB instances, supporting read and write operations and read replicas for high volume read requests. So the service uses endpoints for connectivity and performs automatic backups, allowing point in time recovery and defining backup windows for minimal impact on database service performance. Now let's welcome to the world of Amazon Key Spaces for Apache Cassandra, the ultimate solution for managing your databases in the cloud. So Apache Cassandra is a free, open source, distributed wide column store NoSQL database management system designed to handle large amounts of data across many commodity servers, providing high availability with no single point of failure. Amazon Key Spaces is a serverless, fully managed service designed to be highly scalable, highly available, and compatible with Apache Cassandra, allowing you to use all the same tools and code as you do with your existing Apache Cassandra databases. Boosting unlimited throughput, Amazon Key Spaces is designed for massive scale solutions, allowing you to service business critical workloads requiring thousands of requests per second. It offers extreme performance, scalability, and elasticity, growing at a rate of demand for your applications, ensuring you only pay for what you use. So, using Amazon Key Spaces removes the need for you to manage infrastructure, allowing you to focus on the business logic of the database and your applications, ensuring you get the best performance possible. So Amazon Key Spaces is a perfect choice for applications where low latency is essential and for managing existing Cassandra databases in the cloud without the burden of maintaining your own infrastructure. Now let's dive into Amazon Quantum Ledger Database, where we will explore the features and use cases and integration of these innovative database service. So Amazon QLDB is a fully managed and serverless database service designed as a ledger database, ensuring the immutability and cryptography security of data. Unlike blockchain, QLDB is owned and managed by a central and trusted authority, eliminating the need for a consensus across a decentralized network. So QLDB is ideal for industries like insurance and human resources, providing an immutable framework for tackling extensive process and confidential data, ensuring accuracy and reliability. So the structure of a ledger database in QLDB is based on tables of Amazon Ion documents, maintaining an audit history of all changes through database transactions and cryptography verification. So QLDB uses journal storage to hold the history of changes and index storage for querying, both managed as a fully managed serverless service. QLDB streams allow capturing all changes made to the journal and feeding these information into an Amazon Kinesis data stream in near real time, enabling event-driven architectures and real-time data processing. So let's dive into data lake. A data lake is a centralized repository that allows you to store all your structured and unstructured data in its raw format. It's like a massive, unfiltered reservoir for all your business information. Having a data lake means you can gather data from various sources like transactional systems, IoT devices, mobile apps, and social media. These allows for comprehensive analytics and the potential for valuable insights through methods like machine learning. In today's data-driven world, managing and harnessing the power of your data is crucial. So creating a secure and organized space for all your data to reside is key. And that's where a data lakes comes in. So if you're wondering what makes a good data lake, let's dive into the key components that makes a data lake effective. So first, let's talk about storage. The sheer volume of data can be overwhelming, but AWS offers a solution, S3. It's not only capable of handling large volumes of data, but also unstructured data like log files and binary output. Next, data movement is crucial. Whether it's streaming data with Kinesis, using a direct connection from on-premises, or utilizing the database migration service, automating the process is key. Once the data is in the lake, cataloging and understanding it is essential. AWS Glue provides a managed transform engine with a robust data catalog, making it easier to manage metadata and automate the process. Analyzing the data is where the real value lies. AWS offers services like Kinesis Data Analytics, Amazon Athena, Amazon QuickSight, and Redshift for different analytical needs. So lastly, predictive analytics is made possible through machine learning services like AWS SageMaker and deep learning AMIs, allowing you to gain insights into the future based on your data. If you're trying to build a data lake, let's explore how to do it with AWS Lake Formation. So there are two ways to create a data lake: manually assembling interconnected pieces or using AWS Lake Formation. The latter promises to set up a secure data lake in a matter of days. AWS Lake Formation identifies, crawls, catalogs, and prepares data from various sources like Amazon S3, relational databases, and NoSQL databases. It also handles log files from CloudTrail, Kinesis Firehouse, Elastic Load Balancers, and CloudFront. The services uses blueprints to manage data, allowing you to point to the source data, specifying the loading location, frequency, and customize the process. It also takes care of user security by creating self-service accesses and enforcing permissions across managed services. While AWS Lake Formation doesn't have additional pricing, users need to pay for services like AWS Glue usage, data residency within S3 and Athena queries. So if you're trying to build a data lake efficiently and securely, so consider AWS Lake Formation for a streamlined process. Are you prepared for failure in your AWS architecture? Dr. Werner Vogels, VP and CTO of AWS, famously said, "Everything fails all of the time." This mindset is crucial when designing for failure in the cloud. Let's explore how to improve your AWS architecture to prevent failure. To start, it's essential to grasp the AWS global architecture, focusing on availability zones and regions. Availability zones are the physical data centers of AWS, while a region is a collection of availability zones geographically located close to one another. By deploying resources across different geographical locations, you can add high availability into your design. Let's revisit a basic design scenario and see how we can enhance it. By utilizing multiple availability zones and deploying additional resources such as an application load balancer and a standby RDS instance, you can add high availability into your design in your case of a failure. In the event of a disaster, having the foresight to implement a solution that recovers from a major outage ensures you remain operational and continue to serve your customers. This is high level example of design for failure. When it comes to architecture for design for failure at the global architecture level, you need to determine the business impact of your when your solution becomes unavailable. It's a case of weighing up the cost benefit risk of your deployment design. Designing for failure is AWS is about being prepared for the unexpected. Now let's dive into the world of disaster recovery and understanding the crucial concepts of recovery time objective and recovery point objective. Disaster recovery is all about restoring operations quickly with minimal data loss. RTO is the maximum time a service can remain unavailable before it damages the business, while RPO measures the acceptable data loss between the last backup and the service interruption. To meet RTO and RPO needs, there are different recovery strategies to consider when architecting in AWS for your DR plan. These includes backup and restore, pilot light, warm standby, and multi-site active, each with varying RTO and RPO metrics. Understanding RTO and RPO is essential for building an effective disaster recovery strategy. By implementing the right recovery strategies, you can minimize business impact and data loss, ensuring a stable operational state in the event of disaster. If you're struggling to determine the correct RTO and RPO of your cloud architecture and applications, so let's have some guidance to help you navigate these essential aspects of disaster recovery and business activity planning. It's crucial to access each application individually, as their RTO and RPO requirements will vary. Lower metrics may necessitate more complex architecture and higher cost. So understanding these needs is key. Ask yourself and your team important questions such as impact of application laws, associated cost, service level agreements, dependencies, and regulatory requirements. These answers will help classify RTO in seconds, minutes, hours, or days. Similarly, consider data recreation backup strategies and the rate of data change when determining RPO. These factors will guide your backup strategy and data recovery process. So remember, there's a one size fits all approach to RTO and RPO. It's all about evaluating your internal business factors before designing and implementing your disaster recovery strategy. So if you're curious about the architecture behind the recovery strategy of backup and restore, so let's dive in and explore the key elements of this approach. The backup and restore method provides the longest recovery time objective and recovery point objective values. It's crucial for deployments that don't pose a significant business risk if services are not quickly restored. AWS offers various services for point-in-time recovery, including RDS Snapshot, Amazon Aurora DB Snapshot, DynamoDB Backup, and more. These services provide flexibility and reliability for your recovery strategy. AWS Backup is a versatile AWS managed services that centralizes backup management across multiple regions. It offers fully auditable compliance controls and consolidated logging for your all backups. By implementing a simple architecture using core AWS managed services, you can effectively manage your RTOs and RPOs. Keep in mind that the complexity of your resources and the volume of data can significantly impact your recovery time. Understanding the architecture behind backup and restore strategy is essential for ensuring the resilience of your deployments. So explore the possibilities and optimize your recovery approach with AWS services. So are you familiar with the pilot light recovery strategy? So let's dive into how these approach can help reduce your recovery time and ensure your data is readily available in the event of a disaster. The pilot light method introduces data replication between primary and disaster recovery regions, reducing your recovery point objective and allowing for faster resilience scaling, resource scaling. With continuous asynchronous data replication, AWS services like Amazon S3, RDS, Aurora, DynamoDB, DocumentDB, and Elastic Cache ensure minimal replication latency, significantly reducing RPO in the event of disaster. Imagine a three-tiered web application deployment with the primary region serving customers through a web application accessed via Route 53. The minimal infrastructure in the disaster recovery region includes the VPC, ELB, autoscaling groups, and an Aurora replica, all managed using infrastructure as a code tool like CloudFormation. In the event of a disaster, the secondary ELB can be activated. Application servers provisioned using pre-configured AMIs and the Aurora replica promoted to the primary data store, ensuring a shift recovery. So the pilot light recovery strategy offers reduced RPO and minimal infrastructure in the disaster recovery region. Ensure your data is readily available when you need it in the most. If you are looking to minimize your RTO and RPO greater than what backup and restore or pilot light strategies could offer when planning for a regional failure, then warm standby is your next best choice. Warm standby effectively builds upon pilot light, offering a scaled down version of your primary region up and running in your designated DR region. This reduces your RTO more than what pilot light could offer. The increased cost is due to the additional resources running, but there aren't any other distinguishing features between the two strategies. In the event of a regional failure, the warm standby offering allows your web servers to immediately start processing requests, reducing your RTO. However, you will need to rely on your auto scaling groups to effectively scale out your infrastructure as your workload increases. So by implementing the warm standby strategy, you can ensure a reduced RTO and RPO in the event of a regional failure. Introducing the multi-site active-active recovery strategy. The multi-site active-active recovery strategy offers the lowest recovery time objective and recovery point objective for critical applications and solutions. By deploying infrastructure across multiple regions at full scale, there is no need for failover events to be triggered, ensuring the continuous access to your applications and data. In this configuration, both regions are actively running operational overheads. Route 53 routes traffics based on specific policies. The ELB balances incoming request and DynamoDB global tables handles data replication and continuous backups in both regions. While this strategy offers robust continuity testing the ability of the remaining regions to handle additional traffic and potential data and corruption or deletion are more important considerations. Restoring databases from backup may also affect the RTO. The multi-site active recovery strategy provides unparalleled resilience for critical applications, ensuring seamless access to services and data in the event of the disaster. Are you confused about the difference between high availability and fault tolerance in IT systems? Let's break it down. High availability focuses on maintaining a percentage of uptime to ensure operational performance, often aligned with an SLA. For example, using multiple availability zones and EC2 instances with an elastic load balancer can contribute to a highly available solution. Fault tolerance goes beyond high availability, offering greater protection against component failures. These can involve deploying the system across multiple regions to maintain operation even in the event of an entire region failure. In summary, fault tolerant systems are inherently high available, but not all high available solutions are completely fault tolerance. The choice between high availability and fault tolerance depends on the business impact of potential failures. So remember, it's not if a failure occurs, but when. Now let's do an overview of AWS storage gateway options. So let's explore the different configurations available and when to use them. So file gateways allow you to securely store files as objects within S3, providing a type of file share that can be mounted on mapped drives to an S3 bucket as if it is were held locally on your corporate network. This option is ideal for optimizing latency and reducing egress traffic costs. Now let's discuss some volume gateways. Stored volume gateways are often used to back up local storage volumes to Amazon S3 while ensuring the entire data library remains locally on premises for low latency data access. On the other hand, cached volume gateways utilize Amazon S3 as the primary data storage, with local data storage acting as a buffer. This option is perfect for maintaining low latency with recently accessed data. Lastly, the tape gateway, known as a gateway VTL, allows you to back up data to S3 and leverage Amazon Glacier for data archiving. This cloud-based tape backup solution replaces physical components with virtual ones, providing a robust and secure backup and archiving solution. With these options, AWS Storage Gateway offers versatile configurations to meet your storage needs. Now let's dive into the world of multi-AZ in Amazon RDS. It's a feature designed to ensure resiliency and business continuity for your RDS instance. Multi-AZ stands for Multi-Availability Zone. When configured, a secondary RDS instance known as a replica is deployed within a different availability zone within the same region as the primary instance. This provides a failover option for the primary RDS instance. In the event of an outage, the failover process is automatic and managed by AWS. It typically takes between 60 to 120 seconds depending on the database size and activity. You can configure RDS to notify when a failover event occurs. For SQL Server, multi-availability zone is achieved through SQL Server mirroring, which provisions a secondary instance in a separate AZ for resilience and fault tolerance. Amazon Aurora clusters are fault tolerant by default, but enabling multi-AZ can significantly reduce the time it takes to provision a replica in the event of a primary instance failure. So that's a wrap on multi-AZ in Amazon RDS. Stay tuned for the next segment on RDS read replicas. Now let's explore how read replicas can enhance the performance and resiliency of your database. Read replicas are separate instances that provide read-only access to your database data. They help offload read-intensive traffic from the primary instance, improving overall performance. By deploying read replicas, you can scale your read performance to a wider range of tools and applications. Additionally, you can enhance your disaster recovery capabilities by deploying read replicas in different regions. MySQL, MariaDB, PostgreSQL database engines, read replicas have significant prerequisites and limitations. For example, MySQL read replicas are only supported for databases running MySQL 5.6 or later. It's crucial to monitor the synchronization of RAID replicas with their source database using Amazon CloudWatch. These ensures optimal performance. In conclusion, RAID replicas play a vital role in improving database performance and resiliency. Now let's dive into Amazon Aurora's HA configuration options. Let's explore the key features and benefits that ensures maximum uptime for your applications. Amazon Aurora separates the compute layer from the storage layer, allowing you to adjust data availability. The storage layer is shared among all compute nodes, providing highly redundant and durable data. Aurora uses a quorum and gossip protocol for consistent data and offers automatic failover, ensuring quick recovery in case of a master failure. There are four types of connection endpoints, each serving different purposes. The reader endpoint is ideal for read intensive workloads, while custom endpoints offers flexibility for specific tasks. Understanding these HA configurations option empowers you to make informed decisions on your Amazon Aurora setup, ensuring robust and reliable performance for your applications. Let's dive into some Aurora's powerful configuration options. Aurora can be configured with a single read write master instance and up to 15 read replicas. Replication of data is confirmed asynchronously in milliseconds, providing the impression of synchronous replication. Read replicas allows for increased read throughput and offload database reads from the master instance. In the event of the master instance going down, any read replica can be prompted to take over the role of being master. Daily backups are automatically performed by with a default retention period of 1 day, and a manual snapshots can be taken at any time. Restores are performed into a new database, providing flexibility and security. So introducing Aurora Serverless, the elastic auto-scaling database solution that adopts your application's demands and saves you money by only billing when in use. Aurora Serverless eliminates the need to plan and allocate instance sizes. Instead, you set lower and upper limits of capacity measured in Aurora capacity units. These service continuously adjust and optimizes capacity based on incoming demand, automatically starting and stopping compute instances in seconds. Underpinned by a fault tolerance, self-healing storage layer, Aurora Serverless ensures high availability without the need for manual configuration. It auto-adjusts the compute layer and capacity behind the scenes, scaling up or down as needed. When traffic drops off, it can even shut down the compute entirely, saving you cost on unused capacity. With a single connection endpoint, Aurora Serverless simplifies database access. It also offers the Web Service Data API feature, enabling HTTP web server interface for executing queries without the need for a JDBC driver or connection. This feature is particularly useful for implementing Lambda functions and can be accessed through the AWS CLI. Aurora Serverless performs continuous automatic backups with a default retention period of 1 day, extendable up to 35 days. These backup style allows for restoring to a point in time with the retention period, providing peace of mind for data recovery. Now let's dive into the high availability configuration option available with DynamoDB. By configuring these options, you can maximize the uptime of your dependent applications. DynamoDB automatically partitions data and incoming traffic across multiple partitions stored on backend servers distributed across three different availability zones within a single region. This default setup provides a strong starting point for availability. You can dial up or down the provisioned throughput of the DynamoDB database to ensure it meets the needs of your application as it grows. These results in additional partitions and replications, all happening automatically in the background. Global tables, the latest implementation of cross-region replication, evaluate the availability of your data and enable applications to take advantage of data locality. This feature allows a single table to be replicated across one or multiple alternate regions, protecting your table from regional outages. With DynamoDB's high availability configuration options, you can ensure the high availability of your data and applications. So let's stay tuned and learn more about how to implement these options and maximize the uptime of your DynamoDB dependent applications. If you are looking for a way to request a full backup of a table at a specific moment in time, look no further than on-demand backups. On-demand backups are manually requested and can be performed through the AWS DynamoDB console or by using the AWS CLI. They are useful for scenarios like table corruption, regulatory data requirements, and testing. Scheduling on-demand backups provides the ability to restore table data back to a point in time. They can be requested anytime with no limit to the number or retention period. Plus, backups are completed within seconds and have zero impact on table performance and availability. In the AWS DynamoDB console, we can easily view and restore backups. Once restored, the table contains all the items captured at the time the backup was created. So on-demand backups provide peace of mind and flexibility, ensuring your table data is secure and easily restorable. Now let's learn about point-in-time recovery, PITR. So PITR is an enhanced version of the on-demand backup and restore feature, providing the ability to perform point-in-time recoveries. It's a safety net for data modifications, allowing users to restore back to a specific time, eliminating the need to plan backup schedules. So PITR operates at the table level, enabling recovery for any time between the current time and the last 35 days. Once enabled, users can request a recovery by specifying a date and time with second precision, restoring the data into a new table in the same region or a different region altogether. Welcome to the next part of the crash course, which is architecture. Now let's look into decoupled architecture. In the past, applications were tightly coupled, with changes in one part easily disrupting other services. Coupled architecture, on the other hand, allows different components to operate independently without being closely tied to each other. This means that changes to one component won't affect others, enabling faster and more efficient development. In the event-driven architecture, services are triggered by events that occur within the infrastructure. These events could be changes of state, like an EC2 instance transitioning from running to stopping. This architecture typically involves a producer, an event router, and consumers, with the event routing ensuring that the producer and consumers are decoupled from each other. As you go through these course, we will introduce to Amazon SQS, a commonly used AWS services in decoupled architecture. So stay tuned to learn more about these powerful architectural concepts. Let's dive and understand the capabilities of AWS Lambda and AWS Step Functions. AWS Lambda is a powerful resource for serverless compute, but it has limitations. For complex operations, the 15-minute execution time may not be enough. AWS Step Functions, it acts as a state machine service, allowing you to create interactive and complex systems with complete orchestration and easy of transparency. AWS Step Functions operate by reading in your workflow from an Amazon state language file, providing a visual representation of your state machine right in the console. There are 8 states that your state machine can be in at any time. Include pass, task, choice, wait, succeed, fail, parallel, and map. With AWS Step Functions, you can overcome the limitations of AWS Lambda, creating powerful, fully serverless applications and workflows. Understanding decoupling in application development and messaging services. A decoupled application allows each component to perform its task independently, remaining completely autonomous and unaware of each other. A change in one component shouldn't require a change anywhere else, and a failure in one layer should not propagate to other layers. This is in contrast to tightly coupled applications, where a failure in one layer may negatively impact the following layer and impair the entire application's functioning. Introducing messaging mechanism. Decoupling is made possible by introducing a messaging mechanism, ideally a one-to-one message passing model. The Amazon Simple Queue Service (SQS) is suitable choice for this type of implementation, behaving like an email system for different application layers. It allows for asynchronous connectivity of systems and enables the increase or decrease of EC2 instances processing messages in parallel. Message flow in a queue. The general flow of a message in a queue involves an application producing a message and sending it to a queue, followed by a consumer picking up the message to process it. The message is locked and a visibility timeout is set, ensuring that each message is maintained until the consumer finishes processing it and issues a delete message call to the queue. Managing visibility timeout. The visibility timeout for a message in a queue by default is 30 seconds, with a minimum of 0 seconds and a maximum of 12 hours. If processing a message will take more than 30 seconds, the visibility timeout should be increased accordingly to meet the application's processing time. Let's look into the difference between short polling and long polling in Amazon SQS. Short polling is the default method for listening to messages in a queue. It sends a response even if no messages are available. These can lead to an overlimit error if there are too many in-flight messages. On the other hand, long polling waits for a specified time to collect messages, reducing the risk of errors due to message value. If a message isn't processed successfully, it can become stuck in a cycle. To prevent this, you can use a dead letter queue to capture and examine problematic messages. So understanding the differences between short and long polling, as well as the importance of dead letter queues, is crucial for effective message management in Amazon SQS. If you are a developer looking to simplify the process of message ordering, preservation, and message deduplication logic, well, using FIFO SNS topics in combination with FIFO queues might just be the solution you have been searching for. As developers, we often need to design applications with components that ensure processing a message more than once does not create any errors or inconsistencies. This is known as idempotency. By using an SNS FIFO topic, you can configure a message group by including a message group ID when publishing to the topic. This allows all messages to be sent and delivered in the order of their arrival, while also avoiding duplicate message deliveries through content-based message deduplication. Using SNS FIFO topics and SQS FIFO queues together allows for the implementation of application components that are idempotent by design, simplifying the complex process of message ordering preservation and message deduplication logic. So if you're ready to reduce the effort required to process high throughput, consistently ordered transactions and simplify your messaging architecture, consider leveraging FIFO SNS topics and FIFO queues. Achieve independency at the messaging layer without having to modify your applications. If you're considering migrating your existing data center applications to the AWS cloud, if you're already using messaging APIs like Java Message Service, .NET Message Service, MQ Telemetry Transport, or WebSockets, Amazon MQ might be the solution you're looking for. Amazon MQ is an AWS managed message broker service for Apache ActiveMQ designed to enable seamless migration of messaging and applications without the need to rewrite your code. It's cost effective, automated, and highly available with features like message encryption, network isolation, and seamless integration with Amazon CloudWatch and AWS CloudTrail. So consider Amazon MQ when migrating existing applications that are already using a message broker and you want to keep your applications as they are written. If you are curious about real-time data processing and its impact on modern applications, let's dive into the world of Amazon Kinesis data streams and explore its powerful capabilities. Real-time processing is crucial for applications like the stock market and the Internet of Things devices. Imagine receiving an alert from your home surveillance systems while you're away. It's essential to get that alert immediately. This is where real-time functionality becomes indispensable. Amazon Kinesis data streams is designed for real-time data collection and processing. It contains a copy of received data for up to 365 days, allowing large data sets to be ingested and stored. With the ability to process large data sets in real time, it's a game changer for streaming applications. A stream consists of shards, each storing data records in sequence. Producers put data into the stream and consumers process it using the Kinesis client library. This library ensures decoupled, fault-tolerant, and load-balanced consumption of records from the stream. So in summary, Amazon Kinesis data streams offers automatic data encryption, low put-to-get latency, and the ability to handle gigabytes of data per second. It's a powerful tool for real-time data processing and replaying records to multiple consumer applications. And if you're looking for a seamless way to handle large data sets and deliver them to various destinations, let me introduce you to Amazon Kinesis Data Firehose, a fully managed service that can transform and load your data to destinations like Amazon S3, DynamoDB, and more. Amazon Kinesis Data Firehose takes care of all the infrastructure, storage, networking, and configuration required to ingest and store your data. It automatically scales and replicates data across 3 facilities in a region, ensuring reliability. With buffer sizes ranging from 1 megabyte to 128 megabytes of S3 and the ability to compress and encrypt data, it offers flexibility and security. Unlike Kinesis data streams, Kinesis Firehose does not use shards and is fully automated in terms of scalability. It can seamlessly integrate with various applications and systems, including the Kinesis agent, which is available for Linux systems and web servers. When using Kinesis Firehose, you pay for the amount of data going through it, while it operates fast. It's important to note that there may be latency of 60 seconds or more when storing data to destinations. Amazon Kinesis Data Firehose is a powerful fully managed solution for handling large data sets and delivering them to AWS storage services. With its seamless integration and automated scalability, It's a valuable tool for businesses looking to streamline their data delivery processing. Now let's see how to perform real-time analysis on Kinesis data streams. So let me introduce you to Kinesis Data Analytics. Kinesis Data Analytics allows you to use structured query language to query data in Kinesis data stream and or a Kinesis data firehouse, and then store it to Amazon S3 and OpenSearch cluster or Amazon Redshift cluster. It's a fully managed service with built-in auto-scaling, which can create streams out of real-time queries as a result. For new projects, you can use the Kinesis Data Analytics Studio, which provides you ease of use with advanced analytics capabilities and lets you build streaming processing applications in minutes. With Kinesis Data Analytics, you can harness the power of real-time data analysis and effortlessly build streaming processing applications. Are you curious about stream processing, machine learning, and artificial intelligence within cloud computing? Let's dive into the world of modern stream processing tools and the increasing demand for specialists in this field. Stream processing is the act of reacting to data while it's in motion. Unlike batch processing, which analyzes data in fixed chunks, stream processing allows for real-time reactions to data as it's produced or received. The value of data changes over time, and stream processing addresses issues of latency, session boundaries, and inconsistent load. It's crucial for industries like e-commerce, finance, healthcare, and security that require immediate response to data. Real-time trading in commodities and global product launches are just a few examples of where stream processing plays a critical role. The ability to recognize important events and act on them immediately is essential for businesses in these sectors. So stream processing provides actionable insights within milliseconds to seconds of a recorded event, making it a vital component of modern cloud computing. So now, are you ready to dive into the world of Amazon Kinesis? Let's explore the powerful data streaming services offered by AWS. Amazon Kinesis was designed to simplify the complexity and cost of streaming data into the AWS cloud. It offers an easy way to collect, process, and analyze various types of data streams in real time or near real time. Access to Kinesis is controlled using AWS Identity and Access Management. Data is automatically protected using the AWS Key Management Service and TLS for data in transit. Amazon Kinesis is composed of four services: Kinesis Video Streams, Kinesis Data Streams, Kinesis Data Firehouse, and Kinesis Data Analytics. So Amazon Kinesis provides a comprehensive solution for streaming and analyzing data, offering a range of services to meet diverse data streaming needs. Now let's talk about the power of real-time data streaming with Amazon Kinesis. Streaming data has a wide range of use cases, from industrial automation to IoT analytics and log analytics. Stream processing offers low latency, real time reaction to events, and the ability to match real world process. Real time data streaming involves five layers: the source layer, stream ingestion layer, stream storage layer, stream processing layer, and the destination. Amazon Kinesis is a fully managed framework that provides high availability, durability, and scalability for streaming data. With Amazon Kinesis, you can focus on insights and analysis rather than worrying about streaming infrastructure. Thanks for joining me in this journey through the power of real-time data streaming. If you're looking to process and analyze vast amounts of data, Amazon Elastic MapReduce might be the solution for you. EMR is a managed service designed to handle short and long running workloads, providing high availability and cost efficiency. EMR is based on the Apache Hadoop framework, simplifying the infrastructure layer and reducing complexity. With EMR, you can launch a cluster in minutes, focusing on data processing rather than infrastructure management. Amazon EMR is ideal for various data analytics use cases, including log analysis, machine learning, and scientific simulation. It supports frameworks like Spark, Presto, and HBase, delivering petabyte scale processing power. With Amazon EMR, organizations can efficiently handle big data processing and analytics, leveraging the power of AWS infrastructure and a range of supported frameworks. Discover the power of Amazon managed streaming for Apache Kafka with AWS. Amazon MSK allows you to run applications that utilize Apache Kafka, a platform for stream processing and a publisher subscriber based durable messaging system. Apache Kafka provides stream extreme fault tolerance, preserving the integrity and order of receiving data. It acts as a buffer between data producing entities and subscribers, delivering information on a first in, first out basis for an accurate timeline of produced data. Utilize the native Apache Kafka APIs to create data lakes, stream information to multiple sources, and power data analytics applications and pipelines all within AWS. Amazon MSK is a fully managed service, eliminating the need to handle servers, upgrades, or Apache Zookeeper maintenance. So experience the freedom of build and create with the customizable community-driven tools and add-ons of Apache Kafka, all made accessible and hassle-free through Amazon MSK. Let's discover the core concepts of Kafka. Kafka revolves around three main ideas: producers, topics, and consumers. Producers create data, topics receive the data with extreme fault tolerance, and consumers read the data in order, ensuring it has never changed along the way. Kafka acts as a decoupling mechanism, easing tension among multiple producers and consumers. It consolidates log information from various resources into a single topic, serving as the single source of truth for microservices. Topics in Kafka have configurable retention periods and size-based retention policies, offering flexibility in managing data cost. Additionally, the number of partitions in a topic determines the level of parallelism. Kafka fundamentals concepts of producers, topics, and consumers, along with its role as a decoupling mechanism and its retention and partition features, makes it a powerful tool for managing data flow and processing. When creating your Amazon MSK cluster, there are two key elements to provision: broker instance and broker storage. Broker instances are work nodes that manage the Kafka cluster. They can be run within the same availability zones or across multiple availability zones for a highly available cluster. All data streaming into Amazon MSK is stored in broker storage housed with EBS volumes. These storage gains durability and fault tolerance and can be encrypted using Amazon EBS, server-side encryption, and AWS KMS. An important role about storage is that once assigned, the amount of storage can only be increased, not decreased. However, the broker storage can be auto-scaled upwards if the maximum capacity is reached. Are you a mobile app developer or a marketer looking to drive user engagement? Then you need to understand Amazon Pinpoint. Amazon Pinpoint is a powerful tool that allows you to run targeted campaigns to drive user engagement in mobile apps. It helps you understand user behavior, define which user to target, determine which message to send, schedule the best time to deliver the messages, and then track the results of your campaign. With Amazon Pinpoint, you can send the right data to the right customers at the right time, leading to more effective engagement and increased purchasing. It allows you to create targeted messages that are more likely to interest the users and less likely to cause them to unsubscribe to notification. Amazon Pinpoint provides graphical dashboards for real-time analytics, enables you to create target push notifications, and offers campaign scheduling flexibility. It also includes A/B testing and funnel analytics features, allowing you to analyze and improve the efficiency of your campaigns. So if you want to take your mobile apps to the next level, Amazon Pinpoint is the tool you need. Have you ever wondered how to extract valuable insights from text documents at scale? Let me introduce you to Amazon Comprehend, a powerful machine learning service by AWS that does just that. Amazon Comprehend is a machine learning service that uses natural language processing (NLP) to identify and extract valuable insights from text documents. It can analyze and detect meaningful insights from any text in UTF-8 format or in a semi-structured document such as Word doc or a PDF file. One of the key features of Amazon Comprehend is its ability to produce insights, which is just another way of saying meaningful data. It can extract key phrases, determine sentiment, and recognizes entities such as people, places, events, and more using a range of different APIs. Amazon Comprehend can detect key phrases in text documents and issue a score to determine a confidence level of the detected noun phrases. It can also determine the emotional context of a block of text, generating a percentage score rating for positive, negative, neutral, or mixed sentiment. Furthermore, Amazon Comprehend can recognize entities such as people, places, events, and specific dates and times, attributing a score to determine the confidence of its selection. In conclusion, Amazon Comprehend is a powerful tool for understanding and extracting valuable insights from text documents, enabling you to make data-driven decisions and enhance user. Let's discover the power of Amazon Forecast, a fully managed service that leverages machine learning to provide accurate forecast for time series datasets. Time series datasets are crucial for predicting future data points based on historical trends such as monthly sales, daily inventory, or hourly sensor readings. Accurate forecasting is essential for business success as under-forecasting leads to missed opportunities, while over-forecasting results in wasted resources. This is particularly critical for use cases like capacity planning, demand and inventory planning, and workforce planning, where errors can lead to unused infrastructure, excess inventory, or overtime cost. Amazon Forecast incorporates deep learning algorithms and statistical methods drawing from 20 years of forecasting at Amazon to deliver up to 50% improved accuracy compared to traditional models. It requires no prior machine learning experience, making it accessible to a wide range of users. The service allows for the import of three types of datasets: target time series, related time series, and item metadata. The time series dataset is essential for generating a forecast containing item IDs, timestamps, and associated values. More complex time series can include additional dimensions such as store locations in the case of a retail store. Amazon Forecast simplifies the process with a three-step sequence: data impact, predictive training, and forecast generation. This streamlined approach makes it easy to use, providing completion time estimates for ongoing datasets to import and predict training and forecast jobs. Have you ever wondered where Amazon SageMaker fits into the machine learning ecosystem? So let's dive in and explore its role. At its core, SageMaker is a fully managed service that provides the tools to build, train, and deploy machine learning models. It's where you go when you need to build, train, and deploy models. SageMaker fits into the platform service range along with other popular services like Spark, EMR, Databricks, and Data Robot. It's the go-to platform for everyone from level 2 upwards. The Amazon learning workflow involves four key steps: preparing data, building the model, managing and training, and deploying it into a production environment. SageMaker plays a crucial role in simplifying and streamlining the machine learning process within the larger Amazon ecosystem. Ready to explore the world of machine learning with SageMaker? Let's get started. Let's dive into some architecture basis of multi-tier solutions. So first, let's talk about the LAMP stack. It stands for Linux, Apache, MySQL, and PHP. This stack is commonly used for building web services. Then there is the mean stack, which includes MongoDB, Express.js, AngularJS, and or Node.js. It's an evolving stack pattern that's important to understand. Next, we'll explore serverless architecture and microservices design. Serverless functions using Amazon API Gateway and AWS Lambda can be beneficial in multi-tiered designs. Microservices architecture patterns involves decoupling and independently deploy application components. Now let's clarify the concepts of multi-tier architecture. It involves separating services into tiers or levels such as presentation, logic, or data tiers. These tiers can be scaled and managed independently, providing a workframe for resilient and scalable application components. So lastly, we'll touch on highly available multi-tier architecture, which involves distributing application tiers across multiple availability zones. So this setup provides a highly resilient and scalable architecture, but it's important to note that it's quite complex. That's a wrap on your architecture basis overview. Ever wondered how to define the right tiering when designing in AWS? Let's break it down using a cake analogy. Imagine two cakes, a single layer birthday cake and a multi-layer wedding cake. The single layer cake represents a single tier architecture, while the multi-layer wedding cake represents a multi-tier architecture. In a multi-tier architecture, each layer is independent and can be sealed up or down to meet specific needs. This design suits cloud environments, allowing for truly scalable infrastructure. The most popular implementation of a multi-tier architecture is the three-tier architecture consisting of a presentation tier, a logic tier, and a data tier. Each tier can run on managed infrastructure in the AWS cloud. By separating out the layers, each can operate and scale independently, preventing overwhelming of one tier from impacting the others. This flexibility is key in AWS design. So next time you're designing in AWS, think of it as creating a multi-layered cake. In a single tier architecture, all the application services run on one machine or instances sharing memory, process, and storage. This setup is suitable for simple services, small applications, or dev test environments that don't require frequent scaling. However, to scale a single tier of architecture, you need to vertically scale the instance or machine, which may not be efficient. While running a single tier architecture in AWS can enhance resiliency and scalability, it doesn't allow services to scale independently, posing a availability risk. If high availability and fault tolerance are required, a single tier application should be refactored into a multi-tier architecture. In a multi-tier design, the decoupled tiers can be independently scaled to meet demand, a significant advantage in cloud environments. For applications that don't need to be highly available and fault resistant, a single tier architecture may be considered. However, it's crucial to remember that the decoupled of tiers in a multi-tier architecture allows for efficient scaling to meet varying demands, a key benefit of building applications in the cloud. So let's dive into the world of multi-tier architecture for web services with AWS. Let's explore the design of multi-tier architecture for web services, architecture patterns using instances and load balancers, and how we could create a similar solution using serverless services and a full microservices design. For a multi-tier design, we need to implement the following AWS services. We'll be using the virtual private cloud to build our solution. There are four basic patterns of VPC, each serving different architecture needs. Now let's talk about subnets. A subnet can be either public or private, depending on its internet gateway and route. Public subnets have an internet gateway and a route to it, while private subnets do not. We'll also explore the role of security groups and network access control list ACLs in controlling inbound and outbound traffic at the instance and subnet levels. So designing a multi-tier architecture for web services with AWS involves careful consideration of VPC patterns, subnets, and security measures. So stay tuned for more insights into creating robust and scalable web services architecture. Now let's explore the different connectivity options available within an AWS VPC or a virtual private cloud. One way to provide internet access to instances is by assigning a public IP address or an elastic IP address. For instance, without public addresses, traffic can be routed through a NAT gateway, allowing them to access the internet via network address translation. Highly available NAT gateways offer advantage in deployment, availability and maintenance compared to NAT instances. They are a managed service designed to handle burst activity and scale efficiency effectively. Sorry. Another form of connectivity is using a VPN connection, which allows instances to route their traffic, internet traffic down the virtual private gateway to your own internet connection. So when designing a VPC, always ensure spare capacity for additional subnets and IP addresses to allow for scalability. Explore the various connectivity options in AWS VPC to optimize your cloud architecture. Now let's explore the differences between traditional EC2 instances and serverless service with a focus on AWS Lambda. Let's explore how to choose between EC2 and a serverless service on AWS. So let's start with EC2 instances. There are virtual servers running in AWS cloud, offering a wide variety of instance types optimized for compute, storage, or memory. However, they come with typical server maintenance tasks and associated cost. Whether it's a reserved instances or an on-demand rate, we'll be paying for the instances to be up and running, even if it's ideal for extended periods. Now let's dive into serverless computing. With serverless services like AWS Lambda, you're not responsible for any server. AWS handles the upkeep, maintenance, and security, making them inherently highly available. Billing for services like Lambda is based on actual usage down to the milliseconds level of execution time, offering cost efficiency and flexibility. In conclusion, understanding the trade-offs between EC2 and serverless architecture is crucial for making an informed decision. So stay tuned for more insights on this topic. So are you unsure whether to use EC2 instances or serverless servers for your workloads? So let's break it down. When your workloads is long running, memory intensive, or requires more processing power than Lambda can provide, EC2 instances are the way to go. If your workload has a lot of external dependencies or requires access to the underlying operating system, EC2 instances are also a better fit. And if you are migrating an existing workload from an on-premises environment, EC2 instances are essential for a lift and shift migration approach. On the other hand, if your workload doesn't require extreme processing, memory, or power, and you don't need access to an underlying server, a serverless implementation might be more suitable. Serverless architectures are ideal for unpredictable demand levels and maintaining multiple concurrent versions of your functions. So whether it's EC2 instances or serverless servers, understanding the right fit for your workload is crucial. Make the right choice for your business needs. Now let's dive into the cost comparison between EC2 and serverless architecture. So let's start with the workload deployed as a Lambda function executed 1 milli times per month. The cost just $8.54 per month. But if the demand massively scales up to 100 million requests, the cost skyrockets to over 854 per month. Now let's compare these two deploying the workload on an EC2 instance. With a single instance, the cost is close to Lambda at 9.67 per month. But for high availability, adding a second instance double the cost to just over 19 pounds per month. In conclusion, there's no hard and fast rules when choosing between serverless and EC2. Serverless is ideal for rapid prototyping and event-driven applications, while EC2 is best for complete control over our infrastructure. Always consider your performance requirements and forecasted demand to make the best choice for your use case. So have you ever wondered about serverless architecture patterns? Let's dive in and explore the benefits of using AWS Lambda and Amazon API Gateway for a serverless design. In a serverless architecture, AWS Lambda and Amazon API Gateway provide managed computing and automatic scaling, making it easy to build highly available, scalable, and secure solutions. By using AWS Lambda, you eliminate the need to provision instances, manage operating systems, and worry about over or under provisioning. It also integrates directly with your AWS data tier, ensuring appropriate isolation and access to resources. The API gateway simplifies the deployment, monitoring, and security of APIs, reducing the amount of infrastructure management reduced. It also enables improved API performance via caching and content delivery. So whether it's integrating with the Lambda function or managing communication between code functions and services, the serverless architecture patterns using AWS Lambda and Amazon API Gateway offers a streamlined and efficient approach to building applications. So are you ready to explore the world of serverless architecture patterns? So let's get started. Now it's welcome to a comprehensive overview of various serverless categories and services available within AWS. Let's start by exploring the serverless compute services, which are crucial for any application. AWS Lambda, the pioneer in serverless services, offers event-driven functionality and has evolved significantly since its inception in 2014. When there's AWS Fargate, which allows you to run serverless containers for an unlimited amount of time, overcoming Lambda's execution time limitations. Moving on to serverless application integration services, we have Amazon Event Bridge, a serverless event bus, and AWS Step Functions, a serverless state machine service. These services play a vital role in connecting and managing data between various applications and AWS services. Finally, let's dive into serverless database services. Amazon S3, a scalable object-based storage system, and DynamoDB, a fully managed NoSQL databases, are just a few of the fantastic options available for serverless data storage. So with a wide array of serverless services and categories, AWS offers solutions for almost any application. I highly recommended exploring the coursework of any services that piqued your interest. So grab a coffee, sit back, and let's embark on this journey of AWS serverless exploration. Are you curious about the 7 Rs and why they exist? Let's dive in and find out. The 7 Rs exist to guide organizations in transitioning from an on-premises infrastructure to the public cloud, like AWS. Whether it's migrating a whole data center or hosting an existing application, the 7 Rs help evaluate the most efficient migration strategy that aligns with business requirements. Migrating to the cloud involves addressing all components, not just the application itself. It includes considerations like customer data, communication, security, and ongoing management. So what are the 7 Rs? They are rehosting, replatforming, repurchasing, refactoring, re-architecting, relocating, retiring, and retaining. These 7 Rs provide a framework for focusing on the most appropriate migration method based on specific use case and needs. Are you considering migrating to AWS? Let's explore the different cloud migration strategies to help you make an informed decision. When migrating to the cloud, the lift and shift approach, also known as rehosting, involves moving your application to AWS without significant changes to the core infrastructure. This method is a quick way to move legacy applications to AWS, minimizing disruption and development cost. Replatforming, you can take advantage of managed AWS services, optimizing cost and producing automation and scalability. This approach allows you to move existing databases to a purpose-built environment, paving the way for great growth and innovation. Repurchasing involves acquiring new licenses from AWS Marketplace for applications like ERP or CRM, providing enhanced features and regular maintenance. Re-architecting, harnessing AWS benefits. Re-architecting allows you to fully harness the benefits of AWS by redefining how your solution operates, introducing microservices and event-driven architecture patterns. Relocating to VMware Cloud on AWS enables you to leverage existing VMware tools and skills with AWS infrastructure, integrating with native AWS services for greater innovation and scalability. Identifying valuable applications and shedding the dead weight within your architecture is crucial to streamline the migration process and optimize resources. Remember, a cloud migration doesn't require moving every application. Focus on areas that benefit your business and customers. So if you're considering migrating to AWS, let's explore the three-stage perspective for a successful migration. The first stage, access, involves understanding your current environment and formulating migration goals. AWS Migration Hub and Migration Equalator are key services for this stage. In the mobilize stage, you will define your migration plan and identify any skill gaps. AWS Application Discovery Service and AWS Control Tower are essential for this phase. Finally, in the migrate and modernize stage, you will design your application solution for AWS. Depending on your migration strategy, you will utilize services like AWS Application Migration Service and AWS Database Migration Service. By following these three-stage perspective, you can effectively plan your migration to AWS. Now let's dive into the world of cloud migration with the Migration Evaluator and AWS Migration Hub services. The Migration Evaluator, formerly known as TSO Logic, is your go-to for understanding your on-premises environment and projecting it onto AWS. It analyzes your compute, storage, and Microsoft licenses, providing cost-optimized solution for each workload. And leveraging its agentless collector tool, it can reduce cost by up to 50% when running in AWS. After collecting data for at least 2 weeks, the Migration Evaluator presents quick insights, showcasing assessment results, recommendations, and projected cost. It also provides a breakdown of cost modeling scenarios and full inventory of compute and storage resources. The AWS Migration Hub acts as the nerve center of your migration project, offering a dashboard view to plan, track, and manage your migration. It integrates with other AWS services to discover, audit, and manage the migration of services and servers to AWS cloud services. Now let's explore the AWS migration and modernization services that can help you manage the migration and modernize stage of your migration strategy. We'll cover the services that assist in migrating servers, databases, and applications, as well as how to migrate data from your data center to the AWS cloud. The AWS Application Migration Service is a recommended solution for a migrating application to AWS with minimal downtime and interruption. It works on a lift and shift approach, converting existing physical and virtual machines to run natively across AWS infrastructure. The Database Migration Service is designed to migrate relational NoSQL databases and data warehouses from on-premises environments to AWS with minimal downtime and security in mind. It offers flexibility in migrating to and from different databases, making use of cost-effective DB solutions. The AWS Service Catalog is an organizational tool that simplifies the provisioning and creating of IT stacks, making resources creation easier while maintaining best practices and system security. With AWS Service Catalog, you have full control over what end users have access to, allowing you to apply constraints on the products within your portfolio based on predefined settings. This is just the beginning of your exploration of AWS migration and modernization service. Stay tuned for more insights. If you are looking for seamlessly way to transfer data between your on-premises data center and AWS storage services, look no further than AWS Data Sync. AWS Data Sync is a powerful service that simplifies the secure data transfer between different storage locations. It supports various storage services including Amazon S3, Amazon Elastic File System, Amazon FSx for Windows File Server, and AWS Snowco. With its high-speed data transfer network protocol and end-to-end security measures, AWS Data Sync ensures rapid and secure data transfer. It also supports encryption in transit at rest as well as data validation to maintain the integrity of your data. To begin using AWS Data Sync, you will need to configure your destination storage, grant permissions using IAM roles, set up a transfer family server, and add a user to the server. Then you can seamlessly complete the transfer using a supported client. So experience the ease and security of data transfer with AWS Data Sync. Start simplifying your data management with AWS Data Sync today. AWS No Family. Let's dive into what it is and what it consists of. The AWS No family is a range of physical hardware devices designed to facilitate data transfer into and out of AWS. These devices are essential for transferring data from the edge or beyond the cloud, such as your data center, and can also be used to transfer data out of AWS. For example, from Amazon S3 back to your data center. The Snow family consists of various devices including the Snow Cone, Snowball, and Snowmobile, each offering different storage and compute capabilities. These devices enable you to run usable EC2 instances, process and analyze data closer to the source, and securely store files as objects using File Gateway for Amazon S3. With the AWS Snow family, you can efficiently transfer data at any scale, securely store files, and seamlessly integrate your on-premises storage with AWS. So embrace the power of AWS Snow family for your data transfer needs. Welcome to the part 7 of AWS Certified Solution Architect Associate full crash course. Let's dive into security aspects. Welcome to this overview of identity and access management services. Let's dive into what IAM actually means and how it works. IAM involves two key components, identity management and access management. Identity management is about defining who you are and verifying your identity. For example, your AWS username serves as your unique identity within IAM. Access management, on the other hand, focuses on authorization and access control. It determines what resources an identity can access within your AWS account. These include permissions for specific AWS resources such as EC2 or RDS. Access control is achieved through various authentication methods, including username and password, multi-factor authentication, and federated access. These mechanisms ensure secure access to AWS resources without compromising using user credentials. In essence, IAM enables the management, control, and governance of authentication, authorization, and access control mechanisms within your AWS account. Understanding these security controls is crucial for designing the right level of security for your infrastructure. If you're looking to enhance the security of your AWS account, understanding AWS IAM for secure cloud management is essential. IAM, or identity and access management, is crucial for maintaining security and control over who or what can access your resources. It provides the components to manage access, but it's up to you to configure it securely. You must define access control procedures, restrict user access, set password policies, and consider multi-factor authentication based on your security standards and policies. IAM consists of various components like users, user groups, roles, and policies. Users represent identities while user groups authorize access to resources. Roles allow temporary permissions and policies define access. Managed and inline policies offer different ways to manage access, and federated access allows external credentials for authentication. Access Analyzer helps identify external access to your resources, while the credential report provides insights into user credentials and activity. AWS organizations and service control policies further enhance security by setting boundaries for permissions. So understanding AWS IAM is essential for maintaining a secure cloud environment. So take advantage of these features to strengthen your AWS account security. You probably heard about the AWS account root user. Let's dive into what it is and why it's so important. When you first create an AWS account, it generates the AWS account root user. This user has full access to all resources and features in your AWS account, making it an ultimate administrator. The root user has a huge amount of responsibility and should be used with extreme caution. Specific measures and security restrictions should be linked to the root user to restrict its use and accessibility. There are specific tasks that only the AWS account root user can carry out, such as altering account settings, enabling IAM Identity Center, registering as a seller, activating IAM access for billing and cost management, closing the AWS account, and more. It's essential to understand how to protect the root user. It's recommended to use the root user only for specific tasks and to use an IAM user with administrative privileges for any other administrative action. The root account is powerful and important, so it's crucial to adopt security hardening operations to protect it. Remember, when you're signing in using the AWS management console with the root user, you will need to use an email address different from your IAM user accounts. And welcome to this short course on securing your AWS root user account. Let's dive into some best practices to enhance the security of your AWS root user account. To start, implementing multi-factor authentication for the root user is crucial. MFA adds an extra layer of security, requiring a second step of authentication after entering the password. Next, consider deleting the access keys for the root account. These keys, if compromised, can make your entire account vulnerable. Regularly changing the password for the root account is another essential practice. Ensure the password is strong and unique, using a mix of symbols, numbers, upper and lowercase letters. Lastly, setting up security challenge questions on your account can further improve your AWS account security posture. By implementing these best practices, you can significantly enhance the security of the most important user within your AWS account, the root user. Welcome to a comprehensive review of AWS IAM User Control Dashboard. Let's dive into the key features and functionalities of these essential tools. When you access the IAM dashboard and select users, you will find a summary screen that provides crucial insights into your IAM users. It helps you identify potential security risks, such as inactive accounts with color-coded warnings. The dashboard displays a range of user details, including username, path, groups, last activity, MFA status, password age, console sign-in, access key details, and more. Each of these details offers valuable information for managing user access and security. By leveraging the IAM User Console dashboard, you can efficiently manage your access, identify security risks, and ensure compliance with best practices. It's a powerful tool for maintaining a secure and well-organized AWS environment. So stay tuned for more insights on optimizing your AWS experience. And thank you for watching. Welcome to creating a new user in AWS Management Console. Creating a new user in the AWS Management Console is a simple process. First, set the user details by creating a username, then select the AWS access type, either AWS Management Console access or programmatic access. You can attach permission policies to the user, assign permissions boundaries, and add tags to the users as you would with any other AWS resources. Review and confirm the information submitted before creating the user. Once the user is created, you can download the security credentials via a CSV file containing the username, access keys, and the console login link. And that's it. Creating a new user in the AWS console is quick and easy. Now let's dive into the additional features and security options available for IAM users. First, let's talk about the user details and permissions. We can view the user's permissions, set permission boundaries, and generate policies based on CloudTrail events. Moving on to security credentials, we can manage the user's password, set up multi-factor authentication, and manage access keys. Lastly, the Access Advisor allows us to review the services that users can access and the associated permissions, helping us ensure users have appropriate access. That's a quick overview of the key points for configuring IAM user properties. Stay tuned for more insights on user management and security options. If you're struggling to manage permissions for multiple users in your AWS account, let me introduce you to IAM user groups, a powerful feature that simplifies access management at scale. IAM user groups are subjects that contain IAM users and have IAM policies associated with them. These policies can be AWS managed, customer managed, or inline policies, allowing or denying access to AWS resources. By applying permissions to a group instead of individual users, it becomes easy to modify permissions for multiple users at once, simplifying access management at scale. It's a security best practice to apply permissions to user groups and then associated users to that group, then to associate policies to individual users. Creating a group is a simple three-step process. Give the group a meaningful name, add users to the group, and attach permissions via policies. Once created, you can easily review its configurations, edit permissions, and see other details. IAM user groups are a game changer for managing multiple users in your AWS account, simplifying your access management and enhance security by leveraging these powerful features. Have you ever wondered how IAM roles works in AWS? Let's dive in and find out. IAM roles are identified with assigned permissions, just like users, but they are designed to be assumed by multiple different entities as and when required. When a role is assumed by a user, an AWS service, or an application, a new set of credentials is dynamically created for the duration of that session, without any long-term credentials associated. IAM roles are used for granting temporary access to AWS resources, allowing IAM users in one account to access resources in another, enabling AWS services to access resources on your behalf, and providing federated users with access to specific resources. For every role, there are associated policies controlling access, as well as trust relationship that define who or what can assume the role, such as user, an AWS account, or an AWS service. IAM roles are a powerful tool for managing access to AWS resources, providing a secure and flexible way to control permissions. So next time you need to grant temporary access or enable an AWS service to access resources, consider using IAM roles for a secure and efficient solution. Are you curious about AWS service roles and how they can benefit your AWS resources? Let's dive into understanding the power of AWS service roles and how they can simplify your access management. An AWS service role allows an AWS service to assume a role to access other AWS resources within your own account on your behalf. This is commonly used for EC2 instances, whereby you could create a role for an EC2 instance to assume to gain access to AWS resources on your behalf. By assigning an IAM role to an EC2 instance, you can easily manage permissions and make changes across multiple instances simultaneously. This eliminates the need to manually manage credentials and ensures a more secure and efficient access management process. In addition to AWS service roles, there are also service linked roles, which come pre-configured with specific read-only AWS managed policies. These roles are designed for specific AWS services and provide a secure and controlled way for those services to interact with other AWS resources. Understanding AWS service roles is essential for optimizing access management within your AWS environment. By leveraging these roles, you can streamline access, enhance security, and simplify permissions management across your AWS resources. If you're looking to grant temporary access to AWS resources for a specific user, you need to understand and explore the best approach to these common challenge. When it comes to granting temporary access to AWS resources, The best practice is to allow the user to assume a role with the necessary permissions. This approach replaces all other permissions the user has, ensuring a secure and controlled access. To create a new role with relevant permissions, you will need to define the trusted entity and set up an access policy. This ensures that only specific users can assume the role, preventing unauthorized access. In the AWS Management Console, navigate to the IAM dashboard and follow the steps to create the role with the required permissions. Then add an inline policy to the user to enable them to assume the role. IAM user roles provide a secure way to grant temporary access to AWS resources, ensuring controlled and monitored permissions. If you're looking to understand how federated users can access your AWS resources using roles, let's dive into two options available: Web Identity and SAML 2.0 Federation. When creating a new mobile application that requires access to Amazon S3, embedding long-term credentials into your application code goes against security best practices. Instead, design your application to request temporary credentials from authenticated users through Web Identity Federation. Identity Federation is a method of authentication where two different providers establish a level of trust, allowing users to authenticate from one, which authorizes them to access resources in the other. In the case of your application on AWS, the web identity provider could be Google or Facebook. For example, SAML 2.0 is generally used to authenticate your employees using existing directory services. It's a standard used to exchange authentication and authorization identifiers between different security domains, which uses security tokens containing assertions to pass information about a user between a SAML identity provider and a SAML consumer. Understanding these two methods of federation access using roles in AWS is crucial for managing access to your resources. Whether it's for a large-scale access from unknown user or authenticating your employees using existing directory services, AWS provides the necessary tools for secure and efficient access management. AWS IAM policy types. Let's explore the four main policy types within AWS IAM and how they function. Let's start with the identity-based policies. These policies are attached to users, user groups, or roles, controlling their permissions. They can be either managed or inline policies, offering flexibility in managing access. Moving on to resource-based policies, unlike identity-based policies, these are associated with resources such as S3 buckets or IAM roles. They define which principals can access the resource based on different actions. Next, we have permissions boundaries. These policies set the maximum level of permissions that can be granted to a user or role, acting as guide rails to limit access. Lastly, we will discuss service control policies. These are used at the AWS account level to define the maximum permissions allowed for members, adding an additional layer of security. So understanding these policy types is crucial for effective IAM management. If you're delivering web content through CloudFront distributions, Amazon API Gateway REST APIs, or application load balancers, then you need to hear about the AWS WAF service. The AWS Web Application Firewall service is a crucial layer of security to protect your web applications from harmful and malicious traffic. It helps prevent attacks like SQL injection and cross-site scripting outlined in the OWASP Top 10 list. Implementing AWS WAF is a huge asset to your web application architecture, providing relief to security officers within your organization. It's quicker to deploy and simpler to manage compared to standard WAF solutions. The service is composed of web ACLs, rules, and rule groups, which work together to filter both HTTP and HTTPS requests, allowing only legitimate traffic to be processed. Imagine AWS WAF associated with a CloudFront distribution. The incoming web traffic is filtered using rules or rule groups before it even reaches your CloudFront environment. So by implementing AWS WAF, you can mitigate vulnerability risk and protect your web application from potential security breaches. Let's dive into the world of AWS WAF rules and rule groups. These are crucial for defining inspection criteria to secure your web ACLs effectively. Let's start with managed rule groups. These are predefined rules created by AWS and other sellers designed to protect against specific vulnerabilities. They save time and effort, and each group has a capacity rating, which is important to consider when applying them. Now let's talk about creating your own rules. You can choose from IP set, rule builder, or rule group. For example, with IP sets, you can configure rule criteria based on source IP addresses or IP addresses in headers. The rule builder option allows you to create rules using a visual editor or a JSON builder. Regular and rate based rules are available, each with specific actions and logic options. Lastly, rule group need to be built outside of your web ACL creation. You can create and add rules and specify the maximum capacity WCUs for future planning. Welcome to this overview of AWS Firewall Manager. Let's dive into what this powerful service is all about. AWS Firewall Manager specifies security management across multiple AWS accounts, providing protection for a range of resources. Its ability to work across multiple account infrastructures gives it significant security power. Once security policies are configured, AWS Firewall Manager automatically applies and manages the protection for existing and new resources across all designated accounts, streamlining security efforts across your entire organization. Firewall Manager provides protection for various AWS services and resources, including AWS WAF, AWS Shield Advanced, AWS Network Firewall, VPC security groups, and Amazon Route 53 Resolver DNS Firewall, all closely integrated with AWS organizations. To begin using Firewall Manager, you will need to designate an AWS account as the Firewall Manager Administrator account. Ensure it's part of an AWS organization and configure AWS config for the account and regions where resources reside. With these initial steps completed, you're ready to start configuring AWS Firewall Manager and its policies. Let's deep dive into configuring AWS Firewall Manager policies. Let's explore the different types of policies and their configurations. AWS Firewall Manager allows you to create policies protecting AWS WAF, Shield Advanced, Network Firewall, Amazon VPC, Security Group, and Amazon Route 53 Resolver DNS Firewall. To configure an AWS WAF policy, you will go through a 5-step process. These include choosing the policy and region, describing the policy, defining the policy scope, configuring policy tags, and reviewing and creating the policy. For the AWS Shield Advanced policy, the configuration process is simpler, with steps for describing the policy and defining the policy scope. When configuring the security group policy, you will also select the security group policy type, such as common security groups, auditing and enforcement of security group rules, or auditing and clean up unused and redundant security groups. Understanding the configuration process for each policy type is crucial for effectively managing and securing your resources across multiple accounts. Welcome to a crash course on DOS and DDoS attacks. Let's dive into and understand what these attacks are and how they work. A denial of service attack aims to deny users access to a computer system or application by overwhelming it with bogus requests. On the other hand, a distributed denial of service attack involves multiple sources of bogus requests, making the volume of attacks massive and challenging to mitigate. DDoS attacks require a network of compromised computers known as botnets, controlled by botmasters through command and control servers. These servers are used to remotely send commands to the botnet, initiating a coordinated attack. There are various types of DDoS attacks such as the ping flood and SYN flood. Ping flood overwhelms a victim computer with pings, consuming sufficient bandwidth, while SYN flood attacks to make a system unresponsive to legitimate traffic by consuming server resources. Mitigating these attacks involves careful network design, configuring of protection devices, and having an effective business continuity plan in place. Understanding these attacks is crucial for safeguarding against them. Now, welcome to a quick guide on understanding AWS Shield and its protection levels. AWS Shield is a managed service designed to protect your AWS applications and resources from distributed denial of service attacks by automatically detecting threats that may impact your environment. There are two protection levels offered by AWS Shield. AWS Shield Standard, free and offers protection against common Layer 3 and Layer 4 DDoS attacks. AWS Shield Advanced provides enhanced protection against a wider scope of AWS services, including Layer 7 application attacks, but comes at an additional cost. Enhanced DDoS protection 24/7 specialized Shield response team, Layer 7 protection and integration with AWS WAF, enhanced monitoring and Route 53 health checks, cost protection and integration with AWS Firewall Manager. These are the key features of AWS Shield Advanced. So both versions provide insights into DDoS events, but AWS Shield Advanced offers additional monitoring features and CloudWatch metrics. So before subscribing to AWS Shield Advanced, consider the additional cost and features. Let's discover the power of AWS Security Hub, a tool that consolidates security findings and alerts across accounts and provide products displaying results in a single dashboard. With AWS Security Hub, you can centrally view and manage security alerts, automate security checks, and seamlessly integrate with multiple AWS services like Amazon Guard Duty, Amazon Inspector, and Amazon Metli. It also integrates with third-party products and services, offering over 60 integrations from vendors like Symantec, Splunk, and Palo Alto Networks. Security Hub runs continuous account level configuration and security checks based on AWS best practices and industry standards, providing readiness scores and identifying specific accounts and resources that require attention. So experience the ease of collecting, prioritizing, and remediating security findings with AWS Security Hub, your all-in-one security management solution. Let's discover how AWS Security Hub automatically implements these three fundamental standards as designed by the Center for Internet Security, or CIS, to safeguard your AWS infrastructure against cyber threats. AWS Security Hub supports these standards, which includes enabling multi-factor authentication for all accounts users, defining a robust password policy, and ensuring no publicly accessible Amazon S3 buckets. These actions are crucial for securing your AWS account. These benchmark focuses on AWS configuration best practices for security, including monitoring and logging. Once enabled, AWS Security Hub automatically checks for your compliance with these benchmarks. The PCI DSS standard applies to the storing and processing of credit card information in your AWS implementation. AWS Security Hub serves as your central point of access to verify AWS security and take appropriate action when needed. Take AWS security seriously and ensure that best practices are defined, implemented, and regularly reviewed. AWS Security Hub simplifies the process of collecting and remediating security issues in your AWS infrastructure, helping you protect your business from potential losses. If you're struggling to manage the insignificant volume and categories of security information generated by your services, let's explore how AWS Security Hub can simplify these processes and ensure a secure and compliant environment. The information generated by security services can be overwhelming, making it challenging to maintain a secure and compliant environment. AWS Security Hub provides a centralized platform to access and automatically verify the application of best security practices as defined by AWS experts. Foundational best practices for AWS accounts. When setting up new AWS accounts, it's crucial to adhere to fundamental best practices. These include securing the root user with multi-factor authentication, creating groups with administrator permissions, and provisioning users with access keys and roles. Utilizing groups for permissions and provisioning keys and roles to users is an efficient mechanism for your provisioning. It's essential to avoid storing access keys in code, and EC2 instances are Amazon S3 buckets for maximum security. AWS offers a range of tools, including machine learning based solutions to automate provisioning, monitoring, and auditing for cloud security compliance with best practices. So by implementing these fundamental security best practices and leveraging AWS Security Hub, you can ensure a secure and compliant environment while simplifying the management of security information. Exciting news for AWS users. Let's dive into the integration and benefits of AWS Security Hub. AWS Security Hub seamlessly integrates with Amazon Guard Duty, Amazon Inspector, Amazon Mackie, and more, serving as a centralized platform for security findings. These means that findings from these services are automatically sent to Security Hub, streamlining security management. Security Hub utilizes AWS config rules for security checks and supports integration with Amazon EventBridge for automated notifications and remediation details. These ensures continuous account level security checks based on best practices and industry standards. The platform displays results from over a dozen AWS services, including AWS Firewall, Systems Manager, Patch Manager, and Identity and Access Management Access Analyzer. This comprehensive integration provides a holistic view of security findings. Let's explore the benefits of the integrated services such as Amazon Inspector, Amazon Guard Duty, and Amazon Mackie to understand the value they bring to AWS Security Hub. So stay tuned as we will delve deeper into the benefits and sample findings from these integrated services, highlighting the power of AWS Security Hub. Are you responsible for the security of applications, process, and tools running on EC2 instances? Amazon Inspector is here to help. Amazon Inspector offers a knowledge base with hundreds of rules mapped to common security compliance standards and vulnerability definitions. These rules are regularly updated by AWS security experts. You can also install an agent in the operating system of an Amazon EC2 instance to monitor behavior like network, file system, and process activity. With Amazon Inspector, you can automate vulnerability assessments to make security testing of EC2 instances a regular part of your cloud operations. As a result, you will receive a prioritized list of findings ensuring the security of your EC2 instances. Amazon Inspector, your solution for securing EC2 instances. Protect your AWS accounts. Looking for a reliable way to monitor and protect your AWS accounts and workloads? Amazon Guard Duty is a solution. It uses machine learning models to identify suspicious behaviors and eliminates false positives by learning from your environment. Guard Duty analyzes CloudTrail logs, VPC flow logs, and DNS query logs to provide accurate findings. Sample findings help you understand the results it delivers, and it seamlessly integrates with AWS Security Hub. Results are classified under low, medium, and high severity, with each category marked by a distinct color and symbol. The findings summary gives you a quick overview of the severity categories. Discover and analyze sensitive data stored in Amazon S3 buckets with Amazon Mackey. Using machine learning to identify personal identifiable information like names, address, credit card numbers, API keys, and access credentials. Mackey scans S3 buckets, recognizing critical private information and automatically tracking changes to evaluate new or modified objects in future scans. This approach significantly enhances efficiency and scalability by avoiding the review of unchanged product objects. Amazon Mackey provides a list of findings displaying severity, finding type, affected resources, and the last scan date. For example, it identifies objects with medium or high severity, categorizing them as personal, financial, or credential related, and indicates when the object was last scanned. Are you tired of hustle of setting up user authentication for your applications? So you're not alone. Dealing with user authentication can be tedious and time consuming, especially when determining who is allowed to access specific resources. In the past, user information was stored in traditional databases, requiring significant effort to set up and maintain. But there is a better way. Amazon Cognito, a powerful yet compact service, can streamline the entire process from managing user data to integrate with existing corporate directory services. Say goodbye to the headaches of user authentication and hello to a more efficient application development experience. Welcome to a quick guide on Amazon Cognito, user pools and identity pools. Amazon Cognito user pools are user directories that provide sign in and sign up options for your app users. They also support user profiles, including a customizable user directory that scales to hundreds of millions of users. Now let's dive into Amazon Cognito identity pools. These pools enable you to create unique identities for your users and authenticate them with identity providers. These allow you to obtain temporary AWS credentials to access other AWS services. Understanding the difference between Amazon Cognito user pools and identity pools is crucial for leveraging the full potential of Amazon Cognito. So stay tuned for more insights on cloud services. Introducing Cognito user pools. When signing up new users, Cognito lets you customize what is important for you and your application. You can have your new users submit their emails, addresses, pictures, and more. You can create custom attributes and specify how stringent you want to be with your user passwords. Cognito provides multi-factor authentication and account recovery features, making it ideal for financial services or applications with high value information. Users can sign in using third-party ID providers, and you can also sign in with any SAML identity provider. You can create your own customizable web UI and integrate with AWS Lambda to trigger functions based on user flows. Cognito user pools simplifies the process of user management, authentication, and sign-in, allowing you to focus on developing your application. In the authentication flow, the user submits their credentials, initiating the process. The application then calls the initial authorization operation, signaling to Amazon Cognito the intent to authenticate. If successful, Cognito responds with a token or a challenge, which may include captchas or custom challenges. The client then responds to the challenging using respond to auth challenge. If the user fails the challenge, Cognito can resend a new one. Upon successful authentication, Cognito provides token for the clients to use. Learn about Amazon Cognito identity pools. Amazon Cognito Identity Pools, also known as federated identities, provide temporary access AWS credentials for users or guests needing access to AWS services. There are two types of identities within the identity pool: authentication identities and unauthenticated identities. Each type of identity has a role with policies attached to set permissions for accessing AWS resources. Differentiate between identity pools and user pools. Identity pools are for authentication and access control for AWS services, while user pools are for sign up and sign in operations. All right, let's dive into how authentication works with identity pools. Your application can have the user sign in with Cognito user pools using the user pool itself. Social sign-in, SAML-backed authentication service are similar methods. Once the user sign in, an identity token is sent by the IDP back to the Cognito user pool. This token is then normalized into a Cognito user pool token and stored by Cognito, allowing standardized access to your app regardless of the authentication method. For accessing backend services or APIs, Cognito uses the cup token to authenticate and authorize usage of services like API, Gateway, or Lambda. If your app needs access to services like S3 or DynamoDB, the identity pool is used for authentication, creating an STS token based on the cup token, allowing access to these services. These AWS credentials are linked to an AWS role associated with your user within the identity pool, enabling access to other AWS services. Now let's understand what AWS Identity Federation, what it is and how it works. Identity federation is a method where two different providers establish trust, allowing users to authenticate from one, which authorizes them to access resources in the other. One party acts as an identity provider and the other as service provider. Think of websites where you can log in using existing credentials or authenticate using credentials from a third-party provider like Google or Facebook. This is similar to how identity federation works. AWS offers various services and methods that allow you to access your AWS services via federated access, including Auth 2.0, OpenID Connect, and SAML 2.0. In summary, AWS Identity Federation provides a flexible and scalable way to manage access control systems. Services like AWS Single Sign-On, AWS IAM, and Amazon Cognito play a crucial role in implementing federated access. Thanks for joining me. I hope you now have a better understanding of AWS Identity Federation and services involved. Now let's explore the AWS IAM Identity Center and its core features. IAM Identity Center is a centralized hub for managing user authentication and access to AWS accounts and applications. It simplifies access control for workforce identities across multiple accounts, streamlining security management. One of the key features is the ability to create workforce identities within the center or synchronize them from an existing identity source like Microsoft Active Directory or Okta. It also enables single sign-on access to cloud-based applications, including SAML 2.0 enabled applications. To use IAM Identity Center, you need to be using AWS organizations and tied to your management account. This allows for a multi-account access strategy and centralized management of AWS accounts. In summary, IAM Identity Center provides a seamless single sign-on approach for workforce identities to access multiple AWS accounts and cloud-based applications, making access management more efficient. Let's dive into the high-level steps you need to take to get started with IAM Identity Center in your AWS infrastructure. Before configuring IAM Identity Center, it's crucial to review your current identity sources, such as Active Directory or external identity providers. These will save you time and effort by syncing data from your existing source. Once you have taken care of the considerations, you can enable IAM Identity Center within your management account. Define your identity store, configure permissions for your multi-account architecture, and create administrative level permission sets. Associate these permissions with a group or user within your AWS accounts. If you are using the default identity store, create new users easily within the IAM Identity Center. Finally, use the AWS Access portal to sign in and connect to a wide range of AWS accounts and applications, all without creating IAM users accounts in each AWS account. By implementing IAM Identity Center, you will have a robust authentication system in place, ensuring secure access to your AWS infrastructure. Welcome to our discussions on controlling access with AWS permission sets and groups. So when creating permission sets from within IAM Identity Center, you have two methods to choose from. You can use predefined permission sets such as database administrators, network administrators, data scientists, administrator access, read-only access, and more. Or you could create a custom permission set offering greater flexibility in granting permissions for users or groups. Regardless of the method you choose, there are some configuration elements that apply to both. You need to supply a name for the permission set, specify the session duration and an operational relay state. You can also add an optional tag for management purpose. For custom permission sets, you have the flexibility to add a combination of AWS managed policies, customer managed policies, inline policies, and permission boundaries. You can view the name, description, ARN, and provisioned status of the permission sets in the console. Provisioned means the permission set is in use, while not permissioned means it hasn't been associated with a group or user. It's a good practice to assign permission sets to groups instead of individual users, allowing you to control access for more users at a time. So welcome to a quick guide on application assignments and IAM Identity Center. Let's dive in. To begin, you will need to add your cloud applications to AWS IAM Identity Center. This involves establishing a trust between the application and your IAM Identity Center. You can choose from a library of pre-integrated cloud applications or opt to add a custom SAML 2.0 application. Once you have selected an application such as Slack, you will be guided through the configuration process. These includes providing a name and description of your application, as well as supplying IAM Identity Center metadata details to your cloud application. You will also have the opportunity to adjust optional application properties such as the application start URL, relay state, and session duration. These are optional and can be left blank based on your specific use case. Finally, to assign permissions to your applications for your workforce users, simply select the application from application assignments, choose the required groups or permissions, and assign users. It's simple as that. With these steps, you can seamlessly integrate your cloud applications with IAM Identity Center, providing a single sign-on approach for your workforce users. Let's dive into the service specific settings of IAM Identity Center. Let's explore the key configuration and options available to you. When you access the settings page from the dashboard, you will find essential details such as ARN of your IAM identity center, the region it resides in, an option to set a delegated administrative account and enable identity center applications in member accounts. The delegated administrator account allows you to manage your IAM identity center from outside of your management account, reducing the number of users needing access to the management account and minimizing security risks. You can define whether to share identity information with multiple accounts within your AWS organization and configure the Identity Center enabled applications based on your preferences. The settings page also provides information on identity source, authentication and management, including option for identity source selection, authentication configuration and management controls. Understanding these service specific settings is crucial for effectively managing your IAM Identity Center. So stay tuned for more insights on optimizing your AWS services. Hello and welcome to the part 9 of AWS Certified Solution Architect full crash course. So in this part, we're going to learn about AWS management. So designed to help you prepare for the AWS Certified Solution Architect Associate certification. So in this course, we will cover various management services in AWS, including Amazon CloudWatch, AWS Cloud Trial, AWS Config, AWS Organizations, AWS Control Tower, and AWS Systems Manager. We will also discuss logging options, cost management services, and more. So this course is curated to provide a high-level introduction to the management services in AWS, essential for passing the AWS Certified Solution Architect Associate exam. It's ideal for anyone looking to learn about these services in preparation for the exam. So by the end of this course, you will be fully prepared to sit for the AWS Certified Solution Architect Associate exam. So let's start on this exciting journey. Welcome to an overview of Amazon CloudWatch, your window into the health and operational performance for your applications and infrastructure. Amazon CloudWatch offers a range of powerful features, including CloudWatch dashboards, metrics and anomaly detection, alarms, event bridges, logs, and insights. Using the AWS Management Console, the AWS CLI, or the Put Dashboard API, you can build and customize a page using different visual widgets, displaying metrics and alarms relating to your resources to form a unified view. Metrics are fundamental to CloudWatch, enabling you to monitor specific elements of an application or resource over time. Anomaly detection uses machine learning algorithms to detect abnormal activity. CloudWatch alarms allow you to implement automatic actions based on specific thresholds, while EventBridge provides real-time monitoring and event-driven architecture. CloudWatch logs centralizes log data from different AWS services and insights, provides the ability to get more information from the collected data, including log, container, and Lambda insights. Amazon CloudWatch is a comprehensive service designed to help you optimize your infrastructure and minimize incidents, outages, and errors. Welcome to this overview of AWS Cloud Trial, where we will dive into the fundamental aspects of these essential services. So AWS Cloud Trial is a service designed to record and track events, including API request and non-API request made within your AWS account. These events are captured from various sources such as user-initiated requests, AWS services, and non-API activities like key rotations and signs. Cloud Trial categorizes events into management events, data events, and Cloud Trial Insights events, each providing valuable information about different types of operations and activities within your AWS environment. So by default, Cloud Trial is enabled for all new AWS accounts, allowing you to view and analyze events using the event history. Additionally, you can configure Cloud Trial trails to store, review, and respond to specific events, providing deeper insights and enabling event-driven architectures. There are three types of trails you can create: all region trail, single region trail, and AWS organization trail, each offering unique capabilities and coverage across your AWS infrastructure. AWS CloudTrail and CloudTrail Lakes provide powerful tools for capturing, storing, and analyzing events within your AWS account, offering valuable insights and enhancing security and optimization capabilities. Are you looking to enhance your organization security? AWS CloudTrail is a powerful tool for identifying and preventing security breaches. By analyzing the captured data, you can identify weaknesses in your infrastructure and reinforce official best practices. With Trail and CloudTrail Lakes, you can consolidate activity records from multiple regions into a single S3 bucket. This allows for convenient data analysis, pattern identification, and auditing at scale using queries. Gain enhanced visibility into your AWS cloud environment with CloudTrail. This provides an opportunity to increase awareness of attacks and receive early warnings for unusual behavior. CloudTrail Insights tracks and identifies any abnormal behavior detected within your account based on right API actions. CloudTrail logs provide a recorded audit of actions and configuration changes against your AWS resources, helping you maintain governance and meet regulatory requirements. Each event recorded captured detailed information, including the principal account ID, username, time of the event, and more. Are you looking to set up and create trials within your AWS account? So let's dive into the permissions and access overview for AWS CloudTrail. To start, there are three AWS managed policies related to AWS CloudTrail. The CloudTrail service role policy is a permission policy for a CloudTrail service linked role, while the AWS Cloud underscore full access provides all necessary actions for configuring AWS CloudTrail. Configuring your trials involves specifying a storage location on S3, encryption using KMS, setting notification parameters using SNS, and configuring CloudWatch logs. Specific access is required to carry out these tasks that integrates with other services. When asking CloudTrail to create resources like an S3 bucket or an SNS topic, permissions are automatically applied. However, if using existing resources, these permissions need to be applied manually. The AWS CloudTrail read-only access policy allows actions like get, describe, list, and lookup events, but does not permit creating or modifying trails. So depending on your case, you can use existing AWS managed policies or modify them as needed. So always remember to allocate permissions appropriately based on the user who requires access to AWS CloudTrail. So let's understand CloudTrail event logs and how they can provide valuable insights into your AWS environment. CloudTrail trails capture, track, and retain events across your AWS accounts, allowing you to store and review them for up to 7 years. The log files are written in JSON format and contain detailed information about each event, including the user identity, event time, event source, and more. Let's break down an example event log to understand these information it provides. So we will explore elements like user identity, event time, event source, and request parameters to gain a comprehensive understanding of the captured event. Each log file is given a standard naming format and is stored in a structured manner within your AWS S3 bucket, making it easy to navigate and locate specific log files. So for organizations with multiple AWS accounts, CloudTrail offers the ability to aggregate logs from different accounts into a single S3 bucket, simplifying log management and administration. So understanding CloudTrail event logs is crucial for maximizing the potential value of the data captured, allowing you to effectively monitor and secure your AWS environment. Now let's understand how AWS CloudTrail integrates with Amazon CloudWatch to enhance your monitoring and security capabilities. Enabling your trial events logs to be delivered to CloudWatch is an optional configurable item. You can either select an existing or new log group in CloudWatch and must also select a role to allow CloudTrail to publish to the log group. CloudWatch enables a whole host of security monitoring checks to be utilized. For example, you can be notified when certain API calls request any changes to your security groups or network access control list within your VPC. By sending event logs to Amazon CloudWatch, you can use features like metric filters, CloudWatch log insights, and contributor insights to interpret the data in significant and useful ways. Amazon CloudWatch offers various features that enable you to analyze, identify, monitor, and report on the data captured from within your CloudTrail log files, allowing you to proactively detect security risks, identify performance problems, and resolve potential issues. If you are struggling to maintain consistency in your AWS resources as your fleet grows, let's talk about setting up AWS config to automate the discovery and inventory of your AWS resources. So the first step is to enable the AWS config recorder, which captures changes in your resource configuration and records them as configuration items. Remember, AWS config is disabled by default, so enabling the recorder is essential. Once enabled, the AWS config recorder performs a discovery process, examining each resource and creating a configuration item for each one. These includes global resources like IAM users, groups, roles, and customer managed policies. After the discovery process, AWS config delivers its recording results to Amazon S3 bucket. You can also choose to send detailed information about configuration changes to an Amazon SNS topic or Amazon Event Bridge. So with AWS config, you can automate the discovery and inventory of your AWS resources, ensuring consistency and operational excellence. Are you curious about what's delivered to the Amazon S3 bucket after setting up AWS config? So let's dive into the details. When a configuration item is created for resources, it consists of metadata, attributes, relationships, and the current configuration. This provides information like version ID, resource ID, and more. Configuration history files captures changes to specific resources every 6 hours, while configuration snapshots provide a point in time view of all resources configuration items. Aggregators in AWS config gather configuration and compliant data from multiple accounts and regions, presenting them in a single account and region for easy visibility. So now you know the anatomy of configuration items, the purpose of configuration history and snapshots, and the role of aggregators in AWS config. Let's explore AWS config rules and how they can help you maintain your desired state of configuration. So AWS config provides over 320 managed rules covering over 55 AWS services. These rules can be used as is or customized to suit your specific needs. For example, the Epic attached rule checks if allocated elastic IP addresses are attached to EC2 instances, helping you avoid unnecessary expenses. In addition to managed rules, you can create custom rules using AWS Config RDK, AWS Lambda, and CloudFormation Guard. These tools allow you to define custom logic and policies to evaluate your AWS resources compliance. Once you have selected or defined a rule, configuring its evaluation mode and trigger type is crucial. Whether it's proactive or detective evaluation or based on configuration changes or a specific frequency, AWS Config provides the flexibility to suit your needs. So by leveraging AWS Config rules, you can proactively maintain compliance and best practices across your AWS resources, ensuring cost efficiency and security. Now let's dive into ensure compliance and manage changes effectively within your AWS environment. AWS config provides visibility into compliance status, indicating compliance count for all rules and resources. Resources and rules can be compliant, non-compliant, or have insufficient data. The dashboard offers a clear compliance status panel. For non-compliant resources, remediation can be manual or automatic. Automatic remediation can be triggered when resources become non-compliant with predefined remediation actions available. Conformance packs are a group of AWS config rules and remediation actions that can be deployed as a single logical unit. They can be built using existing templates or customized to fit specific requirements. So AWS config compliance, remediation, and conformance packs offers a comprehensive solution for maintaining compliance and managing changes within your AWS environment. Welcome to an overview of AWS organization and service control policies. Let's dive into the key components and benefits of these foundational service. AWS organizations is a crucial tool for managing multiple AWS accounts with a single organization. It provides a hierarchical structure, including the root, organizational units, and accounts to streamline account management and security. Service control policies, or SCPs, allow for granular control over the accessibilities of services and features within AWS accounts. They act as permission boundaries, ensuring security and compliance across the organization. By leveraging AWS organizations, businesses can achieve centralized management, greater control over their environment, consolidated billing, and effective categorization and grouping of accounts. With AWS organizations and service control policies, businesses can effectively scale their AWS environment while maintaining robust security and governance. So let's dive into the simple process of creating an organization from a master AWS account. To start, choose a standard AWS account to serve as the master account. Remember, it's best practice to use this account solely for administrative purposes. Once the master account is selected, you have the option to create an organization with all features enabled or only for consolidated billing. Enabling all features allow you to set up service control policies. After creating the organization, the master account can invite other AWS accounts to join. The invited accounts owners will receive an email requesting their AWS accounts to join the organization. Finally, the master account can create organization units and move all the accounts into the corresponding units for better organization and management. And that's it. Setting up and configuring AWS organization is a straightforward process that allows for centralized management of AWS services. Now let's dive into service control policies to understand how they can be used to secure your AWS organization. Service control policies are different from both identity-based and resource-based policies, which grant permissions to users, groups, and roles. However, SCPs do not actually grant permissions themselves. Restrictions made within an SCP set a boundary of permissions for AWS accounts. For example, if a user within an AWS account had full access to S3, RDS, and EC2 via an identity-based policy, but the SCP associated with the AWS account denied access to the S3 service, then that user would only be able to access RDS and EC2 despite having full access to S3. To use service control policies to help manage security at an account level, you need to ensure that you deploy AWS organization using the enable all features setting. Before you start using SCPs, you first need to enable them from the root account of your organization. So in conclusion, SCPs do not grant access. They add a guardrail to define what is allowed. If you want to use SCPs within your organization, you need to ensure that you deploy AWS organization using the enable all features setting. So if you're struggling with managing multiple AWS accounts, it's a common challenge, but there's a solution. Let's talk about how AWS Control Tower can simplify multi-account management. Managing multiple AWS accounts can be overwhelming. From provisioning new accounts to ensuring teams follow best practices, the workloads can be daunting. It's crucial to track log files, enforce security rules, and allocate cost effectively. AWS Control Tower offers a centralized method for creating, managing, and auditing multiple accounts. It orchestrates various services, removing the burden of setting up infrastructure and security control individuals. With Control Tower, you can automate account provisioning and apply consistent governance across all your AWS accounts. By using AWS Control Tower, you can streamline the management of your AWS accounts, ensuring centralized identity and access management, logging, and security. Plus, it's free to use with charges only for the underlying services. With AWS Control Tower, you can simplify multi-account management, automate account provisioning, and ensure consistent governance across your AWS accounts. So say goodbye to the complexities of multi-account setup and embrace a more efficient approach with AWS Control Tower. So managing licenses in the cloud can be a headache for asset managers and auditors. AWS License Manager is designed to simplify the management and control of licenses with third-party vendors like Microsoft, SAP, Oracle, and IBM, whether they are used in the cloud or on-premises. AWS License Manager enables the creation of license configuration with customizable rules including license counting type, minimum and maximum allowed number of vCPUs or physical cores, license count, and allowed tenancy. These rules are evaluated against EC2 computer resources to access if licensing limits have been reached. The tool is integrated with AWS System Manager and AWS organizations, allowing monitoring of license requirements across multiple AWS accounts and on-premises environments. It also supports integration with Bring Your Own License from AWS Marketplace. So in summary, AWS License Manager provides a centralized solution for addressing, tracking, monitoring, and managing licenses for on-premises and multi-account AWS environments across multiple third-party vendors using customized rules. AWS Service Catalog, the organizational tool that simplifies IT stack creation and provisioning for both end users and IT admins. AWS Service Catalog allows end users to select pre-approved services, streamlining content creation and ensuring best practices and system security are maintained. Before these, IT and admin professionals had to handle provisioning and service scope, which was tedious and constantly changing. Products are the heart of AWS Service Catalog, representing IT services available for deployment on AWS. They can range from single resources to complex multi-TAD applications and can even include packages from the AWS Marketplace. Portfolios are collections of products with configuration information and they can be customized for different user groups. Constraints allow administrators to control product access and functionality such as launch, notification, tag update, stack set, and template constraints. Service actions empower end users to perform operational tasks, and pricing for AWS Service Catalog is reasonable with a free tier offering up to 1000 API calls per month. So AWS Service Catalog provides full control over end user access, making it a powerful tool for maintaining security and credibility. Now let's understand AWS Systems Manager, a set of fully managed AWS services that enables automated configuration and ongoing management of systems at scale. With Systems Manager, you can manage Linux and Windows instances running on Amazon EC2, your own data center, or other cloud platforms. Systems Manager focuses on automation, allowing you to select the instances you want to manage and define the tasks you want to perform. You can configure maintenance windows, create and update system images, collect software inventory, apply system or application patches, and manage the state of your instances, all from the same console or command line interface. Systems Manager is built for cloud type scalability, enabling you to manage one or thousands of instances regardless of their workloads. It also offers native integration with other AWS management tools such as Identity and Access Management, Cloud Trial, and CloudWatch events. In summary, System Manager provides extensive building blocks and services, allowing you to use automation to manage traditional and cloud workloads while maintaining complete visibility and control over your entire machine farm. Now let's dive into the benefits of Systems Manager. So if you're looking to streamline your AWS configuration and management, Systems Manager is the perfect fit. With the Systems Manager Explorer, you can customize your operations dashboard, view operational data, and manage work items across all your accounts and regions. Plus, you have the flexibility to configure settings and preferences, customize the display, and take action using automated runbooks if necessary. Systems Manager seamlessly integrates with Amazon CloudWatch and personal health dashboards, providing a comprehensive solution for provisioning and operating your resources at scale. With over 20 features and integrations, AWS Systems Manager offers a comprehensive dashboard and essential tools to manage the life cycle of your instances. Some of these features include Fleet Manager, Session Manager, Run Command, Parameter Store, Patch Manager, and State Manager, among others. Most of these features use Systems Manager documents to define operations and maintenance windows to schedule them. These allows you to manage inventory, patch assets, run commands, manage desired state, and securely connect to EC2 instances in private subnets. You can select instances manually, use instance tags, or create resource groups to define the targets for Systems Manager's operations. Resource groups can be tag-based, representing different categories like development tier, production tier, specific owners, departments, or projects. Establishing the best practice of tagging your resources becomes essential to take advantage of Systems Manager features. The tag editor and tag policy editor can help enforce tagging across your resources, making it easier to group and operate on them using Systems Manager. Let's understand the requirements and building blocks of AWS Systems Manager. Let's dive in and explore the key components. So to enable Systems Manager Management Service, the SSM agent is essential. It's the software that needs to be installed and configured on all instances to be called managed instances. The agent is open sourced and available on GitHub and can be installed on various operating systems. Managed instances require an identity and access management role applied as an instance profile. AWS provides predefined managed policies for Systems Manager, such as the Amazon EC2 role for SSM, which can save time in instance configuration. Once configured, managed instances can be viewed in the Fleet Manager feature of the Systems Manager console. This feature provides visibility into details of each managed instances and allows you to connect to instances using the Session Manager feature. The Session Manager feature allows you to connect to any managed instance using an interactive browser shell login without the need for open inbound ports or managing Bastion hosts. It provides full logging and session auditing activity and can control which users can access specific instances using identity and access management policies. So let's discuss a few of the different benefits that logging can bring you and your infrastructure. For some, many people consider logging in after the something that is implemented after it's too late. In hindsight of these situations, logging would have been a great idea to have had running and implemented in the first place to rectify the event quickly and efficiently, or even prevent it from happening in the first place. Logs are created by services and applications which contain a huge amount of information, which is recorded and retained on persistent storage to be reviewed and analyzed at any time that it might be needed. Some logs can be monitored in real time, allowing automatic responses to be carried out depending on the data contents of the log. From an auditing perspective, these logs are invaluable. Being able to resolve an incident as quickly as possible is paramount within your organization. Using logs to ascertain the state of your environment before and after the incident provides clarity and enables you to detect where the incident occurs, allowing you to pinpoint your efforts in a specific area. So, by monitoring the data within your logs, you are able to quickly identify potential issues that you want to be made aware of as soon as they occur. By combining these monitoring of logs with thresholds and alerts, you are able to receive automatic notifications of potential issues, threats, and incidents prior to them becoming a production issue. Now let's explore CloudWatch logs, how they function and how to configure them. CloudWatch is a monitoring service used to collect metrics on resources running on your AWS account, allowing you to monitor their performance and response to alerts. CloudWatch logs, on the other hand, act as a central repository of real-time monitoring of log data. This allows you to monitor log streams in real time and set up metric filters to search for specific events. The unified CloudWatch agent allows you to collect logs and additional metric data from EC2 instances and on-premises services running Linux or Windows operating systems. The agent can be installed on various operating systems, and the installation and configuration process involves creating roles, attaching permissions, and configuring the agent. To install the agent on your EC2 instances, you need to create roles, download and install the agent, and configure and start the CloudWatch agent. The most efficient way to complete this process is by using EC2 Systems Manager service. The CloudWatch logs and the unified CloudWatch agent are powerful tools for monitoring and collecting logs of your applications and various AWS services. So stay tuned for more insights on how to configure and use the CloudWatch agent. Now let's understand Amazon CloudFront access logs. Amazon CloudFront is a content delivery network that speeds up the distribution of your content through its worldwide network of edge locations. When CloudFront access logs are enabled, you can record the request from each user accessing your website and distribution. These logs are stored on Amazon S3 for durable and persistent storage. Enabling access logs for your CloudFront distributions is simple. Just go into CloudFront, select your distribution, and under the General tab, enable logging. You can then select the S3 bucket where you want the access logs to reside. To enable logging, the user account activating that feature must have specific permissions to the S3 bucket designated for logging. Depending on the delivery type of your CloudFront distribution, either web or RTMP, the log output will vary. Understanding CloudFront access logs is essential for monitoring and optimizing your content delivery. So start leveraging these powerful features today. Now let's dive into understanding VPC flow logs and how they can benefit your network security and incident resolution. VPC flow logs capture IP traffic information within your VPC, helping you monitor network communication and traffic flow. This data is crucial for resolving incidents and enhancing security by identifying prohibited traffic. Before setting up VPC flow logs, be aware of limitations. For instance, VPC paired connections and EC2 classic environments have restrictions. Once created, VPC flow logs cannot be altered and have specific traffic exclusions. So you can create flow logs for network interfaces, subnets, and the entire VPC. The log data is sent to CloudWatch logs, and an IAM role is required for permissions to push data to the CloudWatch log group. Setting up VPC flow logs is straightforward and essential for monitoring network traffic. So it's a powerful tool for enhancing security and resolving network incidents. The health dashboard is divided into two main sections: events that affect everyone and events that affect your account's resources. Let's dive into each one. In the events that affects everyone section, you will find open and recent issues. This section displays current issues happening in the AWS platform. If there is not much activity, this option will appear as disabled. Moving on to service history, this section provides a historical view of issues. It's particularly useful for understanding past incidents and their impact on specific services and regions. Now let's explore events that affect your account's resources. This section correlates AWS global issues with the resources and services you are currently using, allowing you to access any potential impact on your business. Now let's dive into maximizing the potential of the Health API. With the Health API, subscribers to businesses or enterprise level support plans can integrate with third-party applications like Jira, Slack, and MS Teams. Plus, the open source tool AWS Health Aware offers automated monitoring and tailored event notifications specific to your AWS accounts. It's all about leveraging the power of the Health API to streamline your AWS experience. So don't miss out on the game-changing capabilities of the Health API. So upgrade your AWS Health dashboard today. If you're looking to gain deeper insights into your cloud environment's cost and usage, let me introduce you to the AWS Cost Explorer, a powerful tool for cloud financial management within AWS. To access the Cost Explorer, head over to your billing dashboard and launch the tool. Once inside, you can visualize your usage patterns over time, identify underlying cost drivers, and detect anomalies. The cost explorers allow you to analyze your cost by different services, view detailed data tables, and even export the data for further analysis in tools like Excel. You can choose the exact time frame you want to see within the cost explorer, from daily to yearly views, and even forecast periods. With the cost explorer, you can segment your data based on specific cost or usage, refine your data sets using filters, and gain insights into usage types and API operations. Explore advanced options like viewing untagged resources, analyzing cost as unblended or amortized, and even factoring in discounts for a comprehensive financial analysis. The AWS Cost Explorer is a valuable tool for managing your cloud financials, providing you with the insights you need to optimize your cost and usage effectively. Let's dive into using AWS reports to monitor EC2 instances. You can build a specific view of your EC2 instances, like for those running in a specific region on a monthly basis. Once you set up, you can save it as a report for easy access. So AWS offers a range of useful reports such as RI utilization and coverage and savings plan utilization and coverage. These reports provide valuable insights into the efficiency of your reservations. With AWS reports, monitoring your EC2 instance become more efficient and insightful. Try it out and optimize your cloud resources. The AWS cost and usage reports is crucial for capturing detailed AWS billing data. It provides historical by the hour data, offering clarity on trends and enabling accurate data driven insights. Without the CUR, valuable usage data older than 12 months is lost. To enable the CUR, go to the AWS Management Console, click on the Billing dashboard and select the Cost and Usage report. Enable it, create a report and include resource IDs for unique identification. Choose an S3 bucket to store the file, set a path and select the time granularity for the data. You can export the files for Redshift or QuickSight usage, changing the output format to be readable for Athena, Redshift, or QuickSight. Athena allows data analysis using standard SQL, while Redshift is a data warehouse service for querying big data sets, and QuickSight is a visually driven business intelligence service. After configuring the options, expect the first report to be delivered within 24 hours. Be aware of minimal S3 storage cost. The CUR is a powerful tool for comprehensive AWS cost and usage insights. Let's do an overview of procurement process. Before the cloud, companies had a fixed procurement process with well understood costs and easier tracking and control. Now with cloud computing, costs are variable, making it more difficult to understand and control procurement cost. So this shift requires better collaboration between application and finance teams to improve planning and cost control. To address these, teams needs to track AWS usage and cost, set appropriate budgets, receive alerts, provide reports to leaders and managers, and take action to automate responses when exceeding budgets. AWS Budgets offers tools to address these needs, including tracking usage and cost, business reporting, and taking action to automate responses. These tools help in defining budgets, setting thresholds, and configuring automated actions. By utilizing AWS budgets, companies can gain better control over their cloud procurement cost, improving planning and automate responses to budget overages, ultimately leading to more efficient and cost-effective operations. Let's talk about automated budget actions in AWS. To manage your AWS spendings. When your budget alert is triggered, you have the option to take three types of automated actions: IAM policies, service control policies, and stopping EC2 and RDS instances. With IAM policies, you can change the permissions of users and roles in your account. For example, you can decrease the level of permissions by changing policies to read-only until until you figure out the budget situation. Service control policies allow you to change permissions at the AWS organizations or organization unit level. For instance, you can limit permissions for specific accounts until resources are shut down. You can also stop EC2 and RDS instances once an alert threshold is crossed, saving cost. You can choose to apply the action automatically or through a manual approval process providing flexibility and control. So by setting up automated responses for budget alerts, you can effectively manage your AWS spending and ensure cost efficiency. Have you ever wondered how to effectively track your AWS costs and usage? Let's dive into understanding AWS cost allocation and usage reports. Tags in AWS allow you to assign metadata to your resources, providing valuable insights into cost allocation. By using key value pairs, you can associate resources with specific business dimensions such as cost center, business unit, or project. The AWS cost and usage report provides detailed billing data, allowing you to track monthly AWS cost and usage with hourly, daily, or monthly reports. You can gain in-depth insights into your AWS spending. Properly managing tags is crucial for effective cost allocation. By implementing a tagging strategy early on, you can ensure accurate and insightful cost analysis. So, in conclusion, understanding AWS cost allocation and usage reports is essential for optimizing your AWS spending. By leveraging tags and the AWS cost and usage report, you can gain valuable insights and make informed decisions about your cloud resources. So start optimizing your AWS spending today by implementing a robust tagging strategy and leveraging the AWS cost and usage report. Cost center, a business unit tag used to show where resources costs are allocated within the organization. Service workload name tag showing which resource the resource belongs to. Resource owner tag responsible for the resource. Simple resource name tag easier to read and remember than default tags. Environment tag determining cost difference between different environments like dev, test, stage, production. So align tags to your cost allocation strategy. Tag everything to track and allocate expenses. Find a purpose for each tag and limit the number of tags to avoid redundancies. Use a consistent naming convention and automate tag management. Set up policies to forbid launching untagged resources and regularly audit and maintain your tags. Let's quickly understand cost allocation tags in AWS. Cost allocation tags in AWS are special tags used by Cost Explorer and other services for allocation and visualization. They can be explicitly used and displayed in various views of different services. To activate cost allocation tags, head to the billing section in the AWS console. Once activated, the console detects all tag keys used and suggests those for activation as cost allocation tags as well. There are two types of cost allocation tags, user-defined and AWS-generated. User-defined tags are created by users and are custom, while AWS-generated tags are automatically created to support AWS resources for the purpose of cost allocation. To enable AWS-generated cost allocation tags, log into your master account as an IAM user with the required permissions. Type billing into the search field, go to the billing console, select cost allocation tags and click on activate to enable the tags. So enabling cost allocation tags is crucial for evaluating certain views in the Cost Explorer and other services, allowing you to effectively track cost incurred for specific resources. Let's dive into the suite of tools available to present and manipulate big data results. Amazon Athena is an interactive query service that makes it easy to analyze data stored in Amazon S3 using standard SQL. It's serverless, so there's no infrastructure to manage and you pay only for the queries that you run. With Athena, there's no need for complex ETL jobs to prepare your data for analysis, making it easy for anyone with SQL skills to quickly analyze large scale data sets. Plus, Athena uses Amazon S3 as its underlying data store, ensuring durability and high availability. Amazon QuickSight makes it easy to build visualizations, perform ad hoc analysis, and quickly get business insights from your data. It has pre-configured reports, taking out the undifferentiated heavy lifting of creating visual reports. With Amazon QuickSight, you can create visuals and scenes that provide information relevant to different business units or reporting agendas and easily share graphs, reports, or business insights as creative stories. So get ready to explore the power of AWS visualization tools and services. Discover the evolution of AWS Glue from an ETL service to a suite of data integration tools. Learn about the Glue Data Catalog, a central metadata repository that stores data about your data. Understanding how it works, from uploading data to storage like Amazon S3 to using a Glue crawler to connect your data source and infer the column name and data type for all your data. Explore how the crawler uses classifiers to identify your schema and create catalog tables with schema data from multiple sources. Understanding the benefit of the Glue data catalog, where your data still lives in the original location but now has a representation of the schema and metadata in the catalog tables. This allows your code to reference the data catalog for information about the data storage location. So let's dive into AWS Glue Studio, a powerful tool in the AWS Glue ecosystem for creating, submitting, and monitoring ETL jobs. Every ETL job in AWS Glue Studio consists of a data source, a transformation script, and a target for exporting the output. In the AWS Glue Studio console, you can create ETL jobs either programmatically or through a visual interface, allowing you to create graphical relationships between a source, transformation scripts, and a target destination. Using the visual interface, you can quickly build an ETL job by selecting a data source, applying a transformation script, and specifying a target destination such as an Amazon S3 bucket. While Glue Studio offers pre-built transformation scripts, it also allows for custom scripts in Python or Scala. However, the built-in transformation scripts are limited with only about 10 options available. For more complex or custom scripts, other development environments may be more suitable. So introducing Glue Data Brew. Glue Data Brew is a true no-code service for transforming data. It allows users to upload data directly to the service or connect to various data sources like Amazon S3, Amazon Aurora, Amazon Redshift, and more. Users can preview the data in a visual interface and choose from hundreds of built-in transformations, including formatting, modifying columns, handling duplicate or missing values, and encoding data. Glue Data Brew is a no-code tool with over 250 plus built-in transformations, creating to business analyst and data scientist. In contrast, Glue Studio is for ETL engineers and provides programmatic opportunities for working with ETL through Jupyter notebooks and shell scripts. DataBrew offers a profiling feature to obtain statistics about the data, such as the number of rows and unique values in each column, which Glue Studio does not have. That's it for this one. Let's jump on to the next topic. Let's do a comparison between Amazon EMR versus AWS Glue for ETL. Before we dive into the details, it's important to note that Amazon EMR offers multiple deployment options, including EMR on EC2 and EMR serverless. So Amazon EMR on EC2 provides maximum control over the service, allowing you to optimize, manage, and scale your cluster and compute nodes. On the other hand, AWS Glue is serverless, simplifying infrastructure maintenance but limiting your choices. While Glue is more expensive at face value, the cost of maintaining an EMR cluster should also be considered. Additionally, with Glue, you can only pay for the time it runs, unlike EMR cluster that may have idle time. Glue has limitations on CPU, RAM, and worker stability, scalability, making EMR a better choice for high performance needs. Furthermore, EMR outperforms Glue for machine learning and data analysis using engines like Presto. So ultimately, if you need flexibility with managing the engine or infrastructure, EMR on EC2 is best. Otherwise, if you require short-lived jobs in an Apache Spark environment, Glue or EMR serverless will save you time by managing the infrastructure for you. So if you are running multiple ETL jobs at varying intervals on AWS, managing these complexity can be challenging. But there are orchestration services available to automate and streamline your ETL pipelines. Let's start with AWS Data Pipeline. This service coordinates data processing from one service to another without human intervention. It's simple in nature, made up of data nodes, activities, and preconditions. Plus, it has retry functionality built in, allowing up to 5 retries per activity. Now let's talk about AWS step functions. This service provides more flexibility, integrating with over 200 AWS services. It's robust, allowing you to make choices between multiple states, pass data between services, and implement delays in your pipeline. So in summary, while AWS Glue workflow is great for Glue components, AWS Data Pipeline is simplistic with limitations, and AWS Step Functions offers sophisticated logic and extensive AWS integration. Choose the right orchestration service to streamline your ETL pipelines on AWS. Now let's dive into AWS Artifact, your gateway to accessing security and compliance reports on AWS. AWS Artifact is a self-service portal that provides immediate access to security and compliance reports. You can view, download, accept, and terminate legal agreements between you and AWS at both the account and organization level. So you might need to access AWS Artifact to provide evidence of compliance for audits, learn about your responsibilities for regulatory standards, or ensure the security to your AWS architecture. AWS Artifact reports include ISO certifications, PSI, and SOC reports, which can be shared with auditors and regulators to provide evidence of AWS security controls. You can also view and execute legally binding agreements between you and AWS, such as the AWS Business Associate Addendum for storing personal health information. AWS Artifact is a crucial tool for ensuring the security and compliance of your AWS solutions. Access it directly from the AWS console and take control of your security and compliance needs. So if you're tired of clicking through countless screens in the AWS console, frustrated with manual errors and updates, there's a solution. By using AWS CloudFormation, you can automate the creation, updating, and deletion of your infrastructure and its configurations all in one place. No more manual errors or time-consuming process. Define your infrastructure in a CloudFormation template written in JSON or YAML format. Apply best practices from software development to your cloud infrastructure. The CloudFormation engine takes your template as input and creates a stack, a collection of AWS resources managed as a single unit. Easily monitor, view, or delete the stack as needed. With CloudFormation, reduce errors, easily redeploy templates, and manage multiple environments effortlessly. So say goodbye to manual errors and hello to efficient infrastructure management. Hello and welcome to the part 10 of AWS Certified Solution Architect full crash course. In this part, we're going to learn about encryption, designed to help you prepare for Solution Architect Associate certification. Are you new to encryption method used by AWS KMS? Let's dive into the basic before exploring the AWS Key Management Service itself. Encrypted data, also known as a plain text or clear text data, can be read by anyone with access. But when it comes to sensitive information, encryption is crucial. Encryption alters the information using mathematical algorithms, and encryption keys, rendering the data unreadable. Symmetric encryption uses a single key for both encryption and decryption, while asymmetric encryption involves two separate keys. AWS KMS use both methods, ensuring secure data handling. Symmetric encryption requires secure key transmission, while asymmetric encryption allows the public key to be freely shared. Although symmetric encryption is faster, it carries additional risks. So understanding these encryption methods is essential for securing your data with AWS KMS. Now let's cover the fundamentals of the AWS KMS service. The key management service is a managed service used to store and generate encryption keys that are used by the most AWS service that perform encryption to protect your data. KMS is essential for encrypting data at rest across various AWS services, ensuring the security of your data. There are different types of keys within KMS, including AWS managed, customer managed, and data keys, each serving specific encryption purposes. KMS seamlessly integrates with AWS CloudTrail to track and audit encryption key usage, ensuring compliance and governance within your production environment. In summary, AWS KMS is a crucial tool for generating and managing encryption keys, enabling secure data encryption at rest across multiple AWS services. Now let's deep dive into the AWS Key Management Service and explore its components. The primary keys within the KMS service used for cryptographic operations like encrypting and decrypting data. By default, these are symmetric 256-bit AES GCM encryption keys, ensuring secure storage on hardware security modules. These keys can be used for encryption and signing, creating both a public and private key pair. As a customer, we have a greater control over these keys from a permission and management perspective. There are three types of keys when working with KMS: customer managed, AWS managed, and AWS owned. Customer managed keys offers greater control over permissions and management, while AWS managed keys are automatically generated by AWS service. Hash-based authentication codes are used to verify data integrity and authenticity. Within KMS, HMAC keys are created as symmetric keys at varied lengths and are used to create and verify HMAC codes. Generated by KMS keys, data keys are used to encrypt and decrypt data outside of KMS. They are designed to be used with the AWS encryption SDK, simplifying encryption. Key material is an essential part associated with a key within AWS. Used as a part of cryptographic algorithm, it can be sourced from various secure sources, including AWS KMS, external key managers, Cloud HSM are imported by the user. Implementing key rotation for customer managed keys is security best practice. AWS KMS can manage these rotation automatically, ensuring the security of the key material. Now let's understand the methods available to secure your KMS keys. KMS key policies are resource-based policies tied to your KMS key. They specify who can administer the key, access it for cryptographic operations, and create grants to control temporary access. The key policy document is JSON-based and contains elements such as resource, action, effect, principle, and conditions, much like IAM policies. IAM permissions to access and use your KMS key must be allowed from within your key policy. Without these, IAM statements allowing access to the key will be ignored. Identify your key administrators and key users within the key policy to control administrative actions and cryptographic functions. Grants allow you to delegate permissions on a temporary basis without updating the key policy and are created using the AWS KMS APIs. Remember, when using grants, consider the type of KMS key, the grantee principal, and the delay until eventual consistency is achieved. Start securing your KMS keys effectively in AWS today. Now let's dive into foundational view of the AWS Cloud HSM service. Let's explore the key aspects of these essential service. The AWS Cloud HSM service provides validated HMS that are crucial for protecting cryptographic material and encryption keys. These HSMs adhere to Federal Information Processing Standards 140/2 Level 3, making them ideal for secure workloads with AWS. Cloud HSM offers a dedicated single tenant appliance, ensuring the security and privacy of your sensitive information. It serves as an enterprise class service for secure encryption, key management, and storage, enabling you to deploy compliant workloads within AWS. With Cloud HSM, you can perform various operations including cryptographic key management, hash function computation, data signing, encryption, and generation of secure random data. Cloud HSM supports both asymmetric and symmetric encryption. Asymmetric encryption involves two separate keys, while symmetric encryption uses a single key for both encryption and decryption. Let's explore the interaction between two essential AWS encryption services, AWS Key Management Service and AWS Cloud HSM. When working with AWS KMS, you can create custom key stores to gain greater control over your cryptographic key management. This is particularly useful if you have a specific compliance controls that requires a higher level of key store management. The AWS KMS offers seamless integration with various AWS services, making server-side encryption simple and efficient. It provides a wide range of integrations, allowing you to protect your data with minimal configuration. KMS creates and stores customer master keys, which can be managed and created by you as a customer of AWS. This provides greater flexibility in managing the keys, including rotation, access governance, and key policy configuration. So by creating a custom key store backed by your Cloud HSM cluster, you can seamlessly integrate KMS with AWS services while maintaining the security and compliance of managing your own key material. This allows you to control access to your key material used within the CMKs. Remember, each HSM cluster can only be associated with one custom key stored for KMS, and both the cluster and the KMS creation of the custom key store must be within the same region. If you are using Amazon S3 to store your data, protecting your data is crucial. That's why understanding server-side encryption is essential. Let's dive into the different encryption methods available and how they work. Firstly, let's explore the three server-side encryption options offered by AWS S3, Amazon S3, SSE S3, SSE KMS, and SSE C. Each method has its unique encryption and decryption process, providing different levels of control and security. Starting with SSE S3, when a client uploads object data to S3, it's encrypted using 256-bit AES 256 block cipher. The decryption process involves retrieving the encrypted object data and decrypting it using the S3 master key. So by default, Amazon S3 applies SSE S3 to all uploaded objects. However, you can change the default encryption option to SSE KMS for greater flexibility and key management. So understanding the encryption methods available for Amazon S3 is crucial for securing your data effectively. Whether it's SSE S3, SSE KMS, or SSE C, each method offers unique advantages and control over your encryption keys. Protect your data with the right encryption method for your needs. So if you're looking to enhance the security of your data in transit to Amazon S3, consider client-side encryption. With the S3 encryption client, you can generate a unique symmetric plain text data encryption key to encrypt your object data. This key is then encrypted using a wrapping key, providing an extra layer of security. You have the flexibility to use symmetric and asymmetric keys as well as the option to utilize the AWS KMS service or your own wrapping key. The S3 encryption client acts as the intermediary between your client and Amazon S3, providing data key creation, object data encryption, and wrapping of your data key using your preferred envelope encryption method. Plus, it's compatible with different language implementations. If you're looking to enhance your security posture when working with different secrets within your AWS environment, AWS Secrets Manager can help you protect your sensitive data and streamline your security practices. So historically, developers embedded credentials directly into applications, posing security risks and making password rotation time consuming. AWS Secret Manager solves these by securely storing secrets such as database credentials and automatically rotating them without updating application code. AWS Secrets Manager supports various secrets including database passwords, API keys, and plain text data with built-in Lambda function support for automatic rotation. Your secrets are encrypted using the key management service and can be accessed and controlled using fine-grained IAM identity-based policies and resource-based policies. So creating a secret in AWS Secrets Manager is simple, and retrieving the values can be done programmatically or via the AWS Management Console or CLI. AWS Secrets Manager provides a secure and efficient way to manage your secrets, ensuring enhanced security and streamlined access. So if you're ready to take your security practices to the next level, try AWS Secrets Manager. So ever wondered about the importance of digital certificates and the key features of AWS Certificate Manager? Let's dive in. Digital certificates are crucial for establishing trust in online communication. They enable us to configure secure connections, validate digital signatures, and ensure the integrity of data at rest and in transit. Without trusted digital certificates, we can't trust the public keys embedded within them, making secure connections impossible. Private certificate authorities. Public certificate authorities issue certificates from public facing services, while private certificate authorities are used for internal purposes. Public CAs are already trusted by most operating systems, while private CAs requires manual configurations to establish trust. So AWS Certificate Manager offers publicly trusted certificates for free, eliminating the need to generate key pairs or issue certificate signing requests. It also provides the ability to automatically renew expiring certificates, ensuring seamless operations without downtime. So whether it's about you securing connection with AWS services or setting up a private certificate authority, AWS Certificate Manager has got you covered.